All right, guys. So you can all see the screen and you can all hear me, right?
Yes, sir.
All right. So as I said, today we're gonna focus on the more recent papers. We're gonna work our way down to 2016 just to try to see if we can increase the volume of work in respect to the topics that we want to cover. If we cover all the topics before tomorrow, then what we can do is go back and do the 2015 down to 2012 papers. So we're gonna focus on 2016 to 2022 and add the specimen paper to it. So what you see on the screen right now is the specimen paper. And we're gonna start with differentiation today. All right, so I still know that there are a couple topics over in module 1 to do, like inequalities and so on. So we'll eventually try to get to those and linear reduction. Still know that we have those to do. All right, but I feel it's important that we come and do some differentiation and integration today. We also have the probability statistics to do. I'm gonna go straight also into the kinematics, the differentiation, integration kinematics when it comes up. I'm not gonna skip over it. All right, because we start running out of time. I know persons have biology tomorrow, and so I want to make today an efficient session. If we don't have to keep a session tonight, then that will be good. All right, so let's go. So remember, it's a revision session, and so I'm not teaching these things from scratch. So I assume that you would have learned, the basics already, and we are just revising. So this first question is on the specimen paper. It wants us to differentiate this thing with respect to x, and that's a product. This little dot inside here means multiply. So differentiating that function. So if I were to rewrite it, it is really y equals 2x sine 2x. And we have to treat this like a product. So we are using the product rule. Now, a lot of persons teach the product rule with some UV business. We don't need to use that U. All right? How you differentiate that product is that you keep the first one and differentiate the second one, plus keep the second one and differentiate the first one. That's all we have to do. All right? To differentiate our product. All right, so let's do it. And when we differentiate in this sine function, remember we have to differentiate the 2x as well to get 2. And the differential of sine is cos. We differentiate a sine function, it becomes a cos function. So ready? So dy by dx on this will be equal to, keep the first, which is 2x. I'm going to put the differential of the second in a bracket. So I'm differentiating this sine 2x, I have to differentiate the 2x first. I get 2. Then I differentiate the sine 2x, I get cos 2x. I have to put by the same function here, cos 2x. So all I've done so far is I've kept the second, I've kept the first, differentiated the second. Plus, I'm now going to keep the second, which is the sine 2x. Keep the second, let's put it in a bracket, and differentiate the 2x, differentiate the first. I differentiate 2x, I'm going to get a 2. So I'm multiplying that by a 2. But understand that?
Yes, sir.
Good. And then we just put a simplified expression. This expands out into 4x cos 2x plus, and this becomes 2 times sine 2x. 2 times sine 2x. And that's the answer right there. dy by dx is equal to that. Nice and easy. All right. Here now is our typical question. It gives us this function that is a quadratic function, and it has a gradient of that. Let me see what they want us to do. So using the principle of differentiation, find the values of the unknown. All right. So they're telling us, they give us this function, and they're telling us that this is a gradient. In other words, when we differentiate this, this is what we're gonna get, because you get the gradient by differentiating. And what it is that once we differentiate this, we're gonna get an expression with the P and the Q in it, and we're gonna have to compare it to the values that exist on this. So they're basically telling us that the dy by dx is in fact equal to this. Dy by dx, when we get it, it is actually equal to 6x minus 6. And when we differentiate this now, it's supposed to be equal to the 6x minus 6. That's what they basically say, right? It says it has a gradient of that at a stationary value. Let's read it fully. So it says the function this has a gradient this at a stationary value of -2. So the stationary value, remember, is when dy by dx equals 0. And it is a y value. It is a y value when dy by dx equals 0. So this is the y value, the stationary value when dy by dx equals 0. Using the principle of differentiation, find the values of the unknown variables p, q, r, and hence determine the function. In other words, this is going to be the function. All right. So going back to this information, this is saying that the stationary value is 2. So we can write that y stationary, which is a minimum. But it don't have to be a minimum. It depends on the value of p. Y stationary is equal to -2. This is the stationary value when dy by dx equals 0. All right. So we can literally put this equals 0 and get that stationary point. But anyway, when we differentiate this, we're gonna get, we have y equals px squared plus qx plus r. We differentiate this dy by dx, they're gonna give us our gradient function. Dy by dx is equal to 2px plus qx plus q. We differentiate this, we get this. We differentiate this, we get this. And so if we compare these values right now, we can see that the 2p equals 6 and the q equals -6 if we compare them. All right? Because this and this is the same. So we can draw that conclusion and say therefore, 2p equals 6, which means that the p equals 3, and the q is -6. The q is -6. So all we need to find out is the r, right? What do we know? We know that the stationary value is -2 when the gradient function equals 0. So this is -2 when this thing equals 0, when dy by dx equals 0. So when this equals 0, you're gonna get the x equals 1. But can see that?
Yes,
X
sir.
equals 1. Good. So it means that this 1, -2 is your stationary point. It means that your stationary point is 1, -2. And this stationary point satisfies this equation. So we can basically plug this stationary point into the equation. Remember, you know, we already know the p and the q, you know. So our equation up front then becomes this. This equation, write it with the p and the q, it becomes y equals 3p squared, the q is -6, minus 6x, so I have that better, minus 6x plus r. To find this r, we substitute these values in the equation because it is a point on the it's a point on the curve, right? So I'm going to substitute the point in the curve. So we can say at, this is a different color here. We can say at 1, -2, which is the stationary point. We substitute the values in there. We're going to get -2 is a y value. I put p, this should be 3x squared, not x, 3x squared. Times 3 times 1 squared minus, change by the color, sorry. Right, so it becomes 3 times 1 squared minus 6 times 1 plus r. And from this we can find the r. This is 3, this is -6. 3 minus 6 is -3. -3 goes on this side to become a +3. 3 minus 2 is 1. And therefore the r is equal to 1. Whether the r is equal to 1, we can now write the function fully. So these are the answers, and underline them. So these are answers. P, Q, that's an answer. This is an answer. And this r is an answer. And then also told us to write the function, right? Determine the function y. So we're gonna put back the values in the function now and write y equals 3x squared minus 6x plus 1. And that is our function. This is also an answer. I like this question. It's a nice question. So test your knowledge that at a stationary value, the gradient, which is dy by dx, that is the gradient, it is dy by dx, is equal to 0. And that's a stationary value. That's a y value at the stationary point. That stationary point is obtained by putting this thing equals 0. And that's how we got this 1. And so the stationary point becomes the 1 and the stationary value. The 1 and the stationary value. And we also have to know that when you differentiate this, that is when you get this, the gradient function. And therefore this and this, they are the same. And so we could equate the coefficients or equate the values and end up with the P and the Q. But understand that? Just want to make sure we understand it. But good?
Yes, sir.
All right. So that's all that question will be doing. You can look out for something similar to this on the exam, right? All right. So this is a kinematics question, it looks like, right? So better stay here and time. So I think I'm gonna just let us do the kinematics right away. I don't have time to be jumping all over the place anymore. So we're doing the differentiation questions, and then we're gonna do the integration questions, all right? And we'll find these coming up in the differentiation questions and also in the integration questions. Because they are basically pairing the kinematics now with the differentiation and integration, because they're viewing the kinematics as a rate of change. And differentiation really is a study of rates of change. Right? It says figure 1 shows a velocity time graph for 18 seconds of journey of a car. So this is out to 18 seconds here. The journey is made up of 4 sections: AB, BC, CD, and DC. All right. So here the car is going at a constant speed. Here the car is decelerating to 0 to rest. Here the car is at rest, not moving. And here the car accelerates again. All right? It accelerates again. Remember, distance traveled is area under the graph. So if we want the distance traveled in this first segment from A to C, I have to calculate that area. Remember also that gradient is acceleration. So here it is decelerating because the speed is dropping. Here it is accelerating. Here. So if we want the acceleration, we have to calculate this gradient, rise over run. All right. Let's see what they want us to state. They say state what is happening at BC. Here it is decelerating from 20 meters per second to rest. And it took, how many? It took 5 seconds to do it. Tell them everything. Decelerates from 20, decelerates uniformly because that's a straight line. Tell them everything. All right? Don't just say decelerates. They say state what is happening. Tell them everything. Say everything. So it decelerates from 20 meters per second to rest in 5 seconds. 5 seconds. All right? So it decelerates from 20 meters per second to rest. I can write the meters per second this way as well with the slash R, slash S. Decelerates from 20 meters per second to rest. Here's when the velocity becomes 0. The term we use for that is to rest. It decelerates to rest. And it took 5 seconds to do it. 5 seconds to do it. 5 seconds, in 5 seconds. But go to that?
Yes, sir. Yes, sir.
Good. What's happening in CD? It is at rest for 3 seconds. It is at rest for 3 seconds, not moving. At rest, it is stays at rest for 3 seconds. For 3 seconds. That's what happened in that segment. That's it. Remains at rest for 3 seconds. That's CD. What happened between C and D right here is that it remains at rest for 3 seconds. What go to that?
Yes, sir.
All right, good. Next part. Calculate the acceleration of the car between D and E. The acceleration between D and E. That's right here. Acceleration is gradient, which is simply rise over run. Rise over run. That is all. So the rise of the read the scale up here now comes all the way up here. So it comes all the way up to 25. But when it reaches up here, it reaches a speed of 25. Between 20 and 30, that's 25. So here's 25. So it rises 25 up to here, and it runs for between 12 and 18 is 6 seconds. It runs for 6 seconds. So it rises 25 and runs 6. Now let me just ask you something. Let's answer that first. So the acceleration is the gradient. We're gonna write that. The acceleration equals the gradient. And I will say it's a gradient, it is a rising gradient. Acceleration is rising gradient. Rising gradient. That's what acceleration is. Deceleration is falling gradient. So acceleration is rising gradient. That's what it is. Acceleration is rising gradient. I'm going to tell you why I say rising gradient just now. It is a rising gradient. So the rise over the run becomes a rise over the run. Simple as that. The rise is 25 meters per second over a run of 6 seconds. 25 over 6, we can just leave it like that. No problem. We have to work it out in this one, and it is meters per second squared. That is it. 25 over 6 meters per second squared. Now, suppose a question had asked us, for example, I'm going to explain the rising gradient to you now. Why I said the rising gradient. Suppose a question asked you for the deceleration from B to C. Deceleration or the retardation. Deceleration is falling gradient because the speed is cutting. So you don't put any negative on the deceleration. So the question asks for the deceleration between B and C. It is a falling gradient, so it will be the fall over the run. And the fall will be 20 and the run would be 5. So the deceleration over here, let me spell that properly. Deceleration would be fall over run. Deceleration is always a fall. And the fall will be 20 and the run will be 5. And that will work out to be 4 meters per second squared. If they wanted the deceleration on that segment. But understand, don't put any negative on it. If they want the acceleration on this segment, then you have to put it as a negative acceleration. But go to that?
Yes, sir.
Good, good. So the acceleration, remember, is a rising gradient. Deceleration is a falling gradient. So it's fall over run or deceleration. Anyway, that's the answer. Question says, in which of the 4 segments of the journey does the car cover the greatest distance? Justify your answer. Justify your answer. So remember, the distance is the area under the graph. So you basically want to see which area had the largest, which area was the largest. That's what you want to find. So look back at the graph. Remember, there are 4 segments. There are 4 segments. So if I break it down, then this is really segment 1. Let's number them 1. This is segment 1, segment 2. Segment 3, actually there was no distance covered because there's no area there. No distance covered. It was at rest. And then segment 4 would be this triangle right here. Segment 4. It's looking like segment 4 to me, but I'm not sure. Now clearly, segment 1 you cover greater. Well, I don't. Let's not assume. Let's just calculate all those areas. Well, we don't need to calculate area 3 because area 3 is clearly 0. So calculate area 1, area 2, and area 4 and see which one of them is larger. And then we can declare which one cover the greatest area, greatest distance, okay? Because distance is area under the graph. So let's do it like this down here. Area 1. All right, let's tell the examiner first that distance is area. So we're going to say distance equals area. Distance equals area under the graph. That's right, distance is equal to area under the graph. Distance on our velocity time graph is area. We're going to do area 1, and I'm leaving these marks on the graph, you know, guys. The A, the 1, the 2, the 3, and the 4. I'm leaving them. So I'm going to do area 1. It's a picture to go back and forth, but I'm going to do area 1 first, which is just 20. I remember it was 20 times, what was it? 20 times 5, right? 20 times 4. That was 4. 20 times 4. And then this one is half of 20 times 5. Half of 20 times 5. So first is 20 times 4, the first area. And then area 2 is half 5 times 20, because half base times height. Half base times height. Hold on a second. Half base times height right here. Area 3 is clearly 0. And area 4, let's look at area 4 now. Remember, it went up to 25, and the base was what? The base right here, so was 6, and it went up to 25. 25, right? So it's half 6 times 25 for the area 4. Half of 6 times 25. So area 4 is half of 6 times 25. I just need to work out which one. So this one is 80. This one is 80 meters. It went. This one is 50. This one is half of 10 times 5 is 50 meters. This one is 0 meters. And here now is 3 times 25 is 75. So therefore, it did the greatest distance in segment A. And segment A was what? Segment A was A to B. Area 1. See? Nice like that. Area 1. Area 1. A to B. So it did largest distance. I'm going to just write answer. The answer to the question up here. The answer is AB. That's my answer. Huh? Where's this? All right, guys. Better go to that.
Yes, sir.
All right. So let's go now and go to 2022. 2022. So 2022 is right here. I'm going to question number 4. All right, searching for question number 4. All right, that's a differentiation question right here. Good. It gives us this question, guys, and it says, given that f of x is equal to this, it's just like saying y equals this, same thing. We want us to find f double prime. Means that we need to differentiate it twice. We need to differentiate this twice. Now watch me now. I can differentiate this as a product, you know. But I feel it's going to be much easier if I expand out this perfect square to separate terms and just write it as a cubic function. Expand it out as a cubic function and differentiate it term by term, rather than to be haggling with the product rule and the composite function in there. It's easier to just expand it out into separate terms. I have to do the mathematics the easy way. So I'm going to expand it out into separate terms. So I'm going to write f of x equals x into, expand this perfect square. I'm going to get 25 minus 10x plus x squared. Then I'm going to multiply 2 by this x and get f of x equals 25x minus 10x squared plus x cubed. When you can expand it out into separate terms quickly and easily, do that. Then I can differentiate this twice. Nice and easy. f prime of x is my first differential. Differentiate 25x, I get 25. Differentiate negative 10x squared, I get negative 20x. Differentiate x cubed, I get 3x squared. Then I have to differentiate it again because I want f double prime. F double prime of x becomes, differentiate this constant is 0. Differentiate this negative 20x is negative 20. Differentiate this 3x squared is positive 6x. Done. That's my answer. Nice and easy, quick and fast. If I try to work the product rule and the composite function, too much concentration. Too much concentration required, and we run the risk of making a mistake. All right? So it was easier to just expand it out into separate terms and differentiate it term by term. But good at that?
Yes, sir.
Yes, sir.
Good. Do the mathematics the easy way. This one, differentiate each of the following expression with respect to x. Simplify your answer where possible. So differentiating a sine function and a cos function. Remember, when you're differentiating a trig function, we have to remember to differentiate the function there, the 3x, which is 3. When I differentiate it term by term. So we're going to write it as y equals and just put dy by dx equals and reference it. So differentiating this first, we have to differentiate the 3x and get 3. Then 3 times 2 is 6. I'm going to get 6 first. When I differentiate the sine 3x, I'm going to get cos 3x. Cos of 3x. You understand? Differentiate this cos. The differential of this x is just 1, so you don't need to change anything. When you differentiate cos, you get minus sine, so it becomes minus sine x. And that is it. Very good?
Yes, sir.
I don't do with that. All right. Come down here now. I need to differentiate this product. That's a product. Again, I'm going to call it y equals. I have to use the product rule on it. This becomes a product of two things. This and this. Note that this part of it is a composite function. Function of a function. When you differentiate in a composite function, if I was differentiated 1 plus 2x cubed, I have to differentiate first as if it's just x cubed. And then you have to multiply by the differential of what's inside. So if I was differentiating this by itself, it will be 3 times 1 plus 2x squared multiplied by the differential of what's inside the bracket, which is at 2. That's what I would get when I differentiate the x, 1 plus 2x all cubed. So when I differentiate this part, I have to get the same thing. Just pointing that out to you. But let's proceed now, guys. Let's proceed now. Just wanted to point that out to you. All right? So let's go. I'm going to differentiate this using the product rule. So remember, keep the first, differentiate the second, plus keep the second, differentiate the first. We don't have to write out the UV formula. Ready? dy by dx equals, keep this first thing unchanged. Keep it. Keep the first, which is 1 plus 2x all cubed. Keep that as it is. Differentiate the second one beside there. Differentiate the second. When I differentiate this, I'm just going to get 1. The differential of what's inside there is just 1. The differential of 2 is 0. Put the 1 there, let the examiner see it. Plus, keep the second thing, which is the x plus 2. You want to differentiate this though, because we know the complexity of it, we're going to put it in a square bracket. So differentiate first again as if it was x cubed. And so it will become 1 plus 2x. Forget the 3. It's going to become 3 times 1 plus 2x squared. Then I have to multiply by the differential of what's inside the bracket, which is at 2. But understand that? But good at that?
Yes, sir.
Yes, sir.
Good. And I was simplifying. This one doesn't do anything to this, so this remains as 1 plus 2x cubed. And then this 3 times 2 is 6. I'm going to put the plus 6 out front. Put back this expression, which is the x plus 2. And then write back that, which is the 1 plus 2x all squared. I can leave it like that. That's it. That's good enough. I could factorize this and simplify it. But this is only 3 marks. I'm not going to go any further, and the space is very small. I'm going to leave it like that. But okay with that?
Yes, sir.
All right. I don't think the question is testing your ability to simplify the expression. It is testing your ability to differentiate the composite part and also to use the product rule. And we have demonstrated that. We have used the product rule throughout, and we have differentiated the composite part inside here. So we have demonstrated our ability to satisfy that is required to satisfy what we need to demonstrate in this question. We have demonstrated it. All right, let's continue. This one says determine the stationary points on this function. That's a cubic function. And when you have a cubic function and the cube term is positive, it will shape like this. That's what a cubic function with a positive x cube shape. If the x cube was negative x cube, it would shape like this, meaning that the minimum will come before the maximum. So I know that the maximum will come before the minimum. So the lower x value will correspond to my maximum. The higher x value will correspond to my minimum. I'm using that just as a guide to help myself to ensure that I get it right. All right? Advanced knowledge is always good. But remember, at those stationary points, dy by dx is 0. The gradient is 0 at a stationary point. All right? And they're going to ask me for the nature down here. All right? It says provide details to determine the nature. To get the nature of the stationary points, I'm going to need d2y by dx squared. So it sort of makes sense to calculate both of them from now, dy by dx and also d2y by dx squared. So I'm going to calculate dy by dx. So dy by dx is equal my gradient function. I'm differentiating this. It becomes 3x squared minus 8x plus 4. That's dy by dx. And my d2y by dx squared equals, I'm differentiating this again. Let me shift this up a bit, make it a little bit smaller. No, not that. This. Let's put it up here. So I'm differentiating again. Right? I'm differentiating this to get my second derivative. I need this for the nature. It's going to be 6x minus 8. I need this to determine my nature. This is required for the nature. Now, at the stationary point, this equals 0. At the stationary point, the gradient equals 0. Let's write it. At the stationary points, dy by dx is equal to 0. That is, this is equal to 0. That is 3x squared minus 8x plus 4 is equal to 0. So I'm solving a quadratic equation to get my 2x values at the 2 stationary points. Factorize this. 3x, x, factors of this. The far product and the near product must give me 8. Has to be 2 and 2. That's 6x and 2x, they add to 8x. The 2 signs in the bracket are the same. They are both negative. Negative, negative. So this factor is giving me x equals 2/3. This factor is giving me x equals 2. Those are only the x values at my stationary points. The question says find the stationary points. So I therefore need to find the y value to go with this and the y value to go with that. I get those values by plugging them back into the original function that has y as a subject. So ready, I'm going to plug them into the function to get the corresponding y values. All right, we have a lot of space. Well, let's go. So at x equals 2/3, the y is equal to, I'm plugging the 2/3 in the function up here. So it becomes 2/3 cubed minus 4 times 2/3 squared plus 4 times 2/3. I'm going to put a line and say at x equals 2, I'm doing the same thing. Let me change the color of these so it can be separated. Let me change the color of these. Let me change the color of these. The purple, so we can see it separately. Change it. Let's go again. And change the color of these as well. All right. So at x equals 2, I'm going to plug the 2 again in the function to get my y value. So y is going to be 2 cubed minus 4 times 2 squared plus 4 times 2. I'm going to get my y value there. Let me make this smaller so that we can write this right in the space. Let me make this smaller. All right. Space is really smart to work in, guys. So to be a lot of space to work with. All right. So can somebody work out the y value for me? This one?
So it's 128.
This one is 128?
Yeah.
120 exact with all them thirds under here, so you sure?
So I multiply it in and I started dividing by 3 to get rid of the denominator.
No. You just have to do, no, you're just working out these values, just working them out. You just have to work
okay.
these values. You just have to work out these values. There's no division required or anything like that. Just work out these values. Just work out these values. Just work them out in the calculator. Similarly, just work out these values. Let's put them in the calculator and work them out. Show you. Put them in the calculator.
I got 32 over 27.
That sounds more like something.
Yeah. That's the answer. Yeah.
32 over 27. And then this one, what is this one? That one looks like 8. That's correct? No, not 8. No, that's not right. Then what this one is? This one. Well, that one looks like
0.
0, 0. All right. Yeah, that's 0. Because this is 8 and 8. That's 16 and minus 16. Good, 0. So it means that this one is on the x-axis, right? Because y value is 0. So the two stationary points are, let me write them in red. This x value with this y value is one stationary point. 2/3, 32 over 27. And the second one is 2, 0. 2, 0 on the x-axis. 2, 0. So those are my two stationary points. Answer. All right. If I come up on the curve right here and sort of show them on the curve just so that we can appreciate it, it means that this one is on the x-axis right here. This is the 2, 0 one. And this one is the, what is it? 2/3, 32 over 27. This one up here. 2/3, 32 over 27. That's this one. So the y-axis will be somewhere out here. And the y-axis, it passes through the origin now. See, there's no c value. So it passes through the origin. So it go like this. This is the y-axis right here. Let me draw it in red. This becomes the y-axis right here. The y-axis, it passes through the origin. Right? The graph passes through the origin because there's no c value on it. Like this. As if we were to sketch it. This is the y-axis and this is the x-axis. And that blue is my curve. That's how the curve would be. That's how the curve would be, guys. If we were to sketch it. The more things we understand, the better. Right? That's how the curve would be. So you see that the maximum is this one and the minimum is this one. But the question wants us to show it, and we have to use a second derivative to show it. All right, which is the nature. So let's go. See? Providing details. So in other words, providing details determine the nature of each stationary point. So we're going to use the d2y by d squared, which we calculated up there. Calculated it already. which is 6x. I think this is 6x minus 8 right here. 6x minus 8. So it's 6x minus 8. So we want to know whether it's positive or negative. Remember, the second derivative is positive, you have a minimum point. And if the second derivative is negative, you have a maximum point. All right? If the second derivative is positive, you have a minimum point. If the second derivative is negative, you have a maximum point. All right? Want me to explain why that is so? CSEC, you're not going to ask to explain
Yes,
it.
sir.
All right, let me explain it to you. All right. So the second derivative is a measure of the rate of change of the gradient. That's what it's measuring. Gradient. Remember, we differentiated the gradient to get the second derivative. So the second derivative is a rate of change of the gradient. How is the gradient changing? All right, let's look at it now. If the graph has a smile shape like this, then over here, the graph is coming down first, and so it has a negative gradient. At the turning point, the gradient is 0, and over this side, the gradient is positive. So as you go through a minimum point, the gradient is changing from a negative value to a positive value. Right? So the gradient is changing from a negative through to a positive. So the gradient is increasing. It is increasing. The gradient is increasing. As you go to a minimum point, the gradient is increasing. And when the gradient is increasing, this is positive. It means that the rate of change of the gradient is positive, because d2y by dx squared is now greater than 0, because the gradient is increasing from a negative to a positive as you go through a minimum point. But you understand that?
Yes,
you understand
sir.
that? Because d2y by dx squared is a measure of how the gradient is changing. Gradient is increasing from a negative to a positive as you go through a minimum point. And we can look at the maximum now. Let's look at the maximum to show that the gradient is decreasing as you go through a maximum point right here. When you're going up here initially, the gradient is positive. When you reach a minimum point, the gradient is 0. And then on this side, the gradient becomes negative. Remember, you have to always think of yourself. Rate of change is taken as if you're going from left to right. Along any curve, you're always considering going from left to right, left to right, left to right. So as you go from left to right on the curve, firstly, you are increasing. If you're going to a maximum point, gradient is increasing first, then it becomes 0, then it starts to decrease. So as you go to the maximum point, it decreases from a positive to a negative value. So the gradient at that time, the gradient decreases. The gradient decreases. It decreases. Decreases. So decreases from a positive down to a negative. So the gradient is decreasing, then the rate of change of the gradient is going to be negative. That is when the d2y by dx squared is less than 0, because the gradient is decreasing as you go to the maximum point. And so we will just reverse it. We simplify it and say, if the second derivative is negative, you have a maximum point. But now you know the reason. It is because the gradient is decreasing from a positive to a negative value as you go to a maximum point. And when the second derivative is positive, it is because the gradient is increasing. As you go to a minimum point, the gradient is increasing from a negative to a positive, and that is when the second derivative is positive, means that you're going to a minimum point. All right, so that is the explanation as to why, how the second derivative tells you the nature. But simply put, if the second derivative is positive, you're going to a minimum point. If the second derivative is negative, you're going to a maximum point. All right, so let's work it now. So at the first point here, it's going to be maximum. Right? We know it's a maximum one. We know already. So, but we have to show it. At x equals 2/3, right? The d2y by dx squared becomes 6 times 2/3. 6 times 2/3 minus 8. You don't have to know the actual value. You just need to know if it's maximum or minimum. You don't need the actual value. right? Right now, this is 12 over 3, and this is 24 over 3. So 12 minus 24 is negative. So we know that this is going to be less than 0. Therefore, this point is a maximum. Therefore, 32 over 27 is a maximum point. It's a maximum stationary point. And then you do the other one. The other one is at x equals 2, the d2y by dx squared becomes 6 times 2 minus 8. That is 4. I don't need to know the value. I'm only interested if it's positive or negative. That is greater than 0. And therefore, the point 20 is a minimum point. Don't have a lot of space, but I'm writing it still. That is it. I was still, but go to that.
Yes, sir.
All right. Easy stuff. All right. You just have to kind of be smart with the space. Don't give a lot of space to write. Okay. All right, smaller. All right, that is it. Anything else on this question? All right, that finishes that question. That's 2022. All right, let's go to 2021. Remember, we're only going on to 2016. All right, we're only going on to 2016. So let's go to 2021. 2021. 2021 is right here. 2021. Going on to question 4. All right, question 4. Right here. Nice and easy. Let me close that out so I can get more, get larger. Differentiate this. It's a trig function again. Differentiate this. Let's call it y. Y equals these things. I'm going to differentiate it. dy by dx equals. We differentiate the sign, gonna get cos. This is how we differentiate it. We differentiate sin x, so we're just gonna get cos x straight. We differentiate cos 4x, have to differentiate the 4x first. What the problem is that when you differentiate the cos, you're gonna get negative. So I'm gonna put the negative from now. Then I'm gonna differentiate the 4x and get 4. And when I differentiate cos 4x, I get sin 4x. But it's actually negative sin 4x. But I understand that, and then I put the 4 inside. I differentiate the 4x to get the 4. But I understand that. But good?
Yes, sir.
Yes.
All right, next one. This now is a quotient. Again, a lot of people teach it with d over u or u over v business. You don't need that. You don't need that. Don't need to write that out. To differentiate a quotient, all you have to remember is that you start with the bottom, which is this, and you finish with the bottom squared. Start with the bottom and finish with the bottom squared. What do I mean by that? If you remember that statement, start with the bottom and finish with the bottom squared. This is the bottom. This is what I call the bottom. Start with the bottom and finish with the bottom squared. All right, let's look at it now. So I'm going to differentiate this. I'm going to call it dy by dx. I'm going to call it y. I'm going to say dy by dx equals, I don't need to write no u, nothing. Start with the bottom, meaning I write down the bottom first. 2x plus 1, that's what I write down first. So naturally, I have to now differentiate the top. So I start with the bottom, so it's the bottom, then I have to differentiate the top beside it. When I differentiate the top beside it, I'm gonna get 6x squared. So I start with the bottom and I differentiate the top. Then I know that because a quotient, I have to minus. I have to switch them around now. Now I have to put down the bottom, put down the top and differentiate the bottom. I start with the bottom and differentiate the top, you know. So now I have to switch them around. I now have to put down the top and differentiate the bottom. So I'm going to put down the top now. And I'm going to differentiate the bottom. Differentiate this bottom and I'm going to get 2. And divide all of that by the bottom squared. So look, see here, I started with the bottom and I ended with the bottom squared. Can't go wrong. Start with the bottom, end at the bottom squared. When I write down the bottom here, I have to differentiate the top. Then it is minus the top and then differentiate the bottom over the bottom squared. So let me say it. It is the bottom times the difference of the top minus the top times the difference of the bottom over the bottom squared. Start with the bottom and end with the bottom squared. When I write down the bottom, I differentiate the top. Then I have to switch them around. I know I have to write down the top and differentiate the bottom because I'm switching around the order. Remember, I put a negative inside here. And that is all. We don't have to write down the UV business to do it. But I understand that.
Yes, sir.
If you want to write down the UV and do it, no problem. If you're comfortable writing on the UV business and do it, no problem. I'm not going to write it down. I'm going to do the mathematics the easy way every time. Start with the bottom and end with the bottom squared. Don't need to write down the UV. Equals, I'm going to expand this. I'm going to simplify it, expand that. Let me make this a little small. The space is very small. All right, let me make this a little smaller. Equals. Then I'm going to simplify this. I'm going to multiply this 6x by those two. I'm going to get 12x cubed plus 6x squared. Care for this negative sign now. So it's 2 times d is really, but it's negative 2. So this is really negative 2 times this. They become negative 2 times this gives me negative 4x cubed. And negative 2 times this gives me negative 4. All over the bottom squared. And I can consolidate the values on the top. These are the cube terms. 12 minus 4 is 8x cubed. This is the x term. That is 6x squared. This is the only constant term. Minus 4 divided by 2x plus 1 squared. But I go to that.
Yes, sir.
All right. So remember that, guys. Easy way to do this differential of quotients. Start with the bottom, end with the bottom squared. Remember that you have a minus in between them here when differentiating a quotient. When differentiating, the product rule is a plus. So the product rule is you keep the first one, differentiate the second one, plus keep the second one, and differentiate the first one. So you alternate differentiating and keeping them. And it's a plus. For the quotient rule, you start with the bottom and differentiate the top, minus, keep the top and differentiate the bottom, divided by the bottom squared. So if I were to say it again for the quotient rule, it's the bottom times the difference of the top, minus the top times the difference of the bottom, over the bottom squared. Say it one more time. It's the bottom times the differential of the top, minus the top times the differential of the bottom, over the bottom squared. I start with the bottom, I end with the bottom squared, and you alternate what you differentiate on the top there. And put a minus between them. It's not easy. You don't have to write out the UV. You don't have a lot of space anyway. Write out no U and no V. All right, let's continue. This one says, use the principle of differentiation to compute the stationary values. All I want is the stationary values. They don't want the points now of this function. All they want are the stationary. It's a stationary value. It's a quadratic, a smile shape quadratic. They're asking for the y value down here. And I want to use differentiation to do it. Remember, it's a quadratic, so we could do it by computing the square. Right? Or we can use a calculation method. But I want to use differentiation to do it. I want us to find the stationary value. So at the stationary point, same thing again. We need dy by dx. So that is 2x minus 4. And then at the stationary point, the dy by dx equals 0. The gradient is 0 at a stationary point. A stationary point is where the gradient is 0. So putting this equals 0. 2x minus 4 equals 0. So x equals 2. And to find that stationary value, now I'm going to plug the 2 back in the function. All right? So the stationary value is the y value at the stationary point. It becomes the point where y equals 2 squared minus 4 times 2 plus 2. Y equals, that's stationary point, I put S on it for stationary. YS for stationary. That's 4 and 2 is 6. 6 minus 8 is negative 2. Agree with that? Negative 2. That's a stationary value. Question wants a stationary value. So this is my answer. They did not want the stationary point. They want the stationary value. The stationary point is 2, negative 2. But they want the stationary value. So the stationary value is the Y value at the stationary point, which is that. Answer the question. Everybody good?
Yes,
Everybody
sir.
okay?
Yes, sir.
All right, beautiful, beautiful. All right, so this is a kinematics. We're gonna do it. After doing this differentiation question, it comes up, we're gonna do it. All right, it's a rate of change. It says a motorist starts from a point X and travels 60 meters due north. Due north means it goes towards the north. Simple as that. It goes towards the north, right? To a point Y, and it goes at a constant speed of 4 meters per second. Constant speed. So when speed is constant, you know that speed equals distance over time. When speed is constant, speed equals distance over time. Low time speed equals distance over time is when it has an acceleration. But once the acceleration is 0, speed equals distance over time. All right? Simple as that. Then it says it stays at Y for 25 seconds and then travels at a constant speed of 10 meters per second. Constant speed again, 10 meters per second. And it goes 100 meters due south to a point Z, due south. So it's motion a straight line, this is now, guys. You go north first from X, start at the point X. That's what I said. That's what I said. Start at the point X. You go north from X, bam, to a point Y. And they told us the speed. It got 60 meters up there, 60 meters. 60 meters it took, 60 meters it went, and it got a speed of 4 meters per second. So it got a speed of 4 meters per second up there. So we can find the time that it took to go up there, right? Then it stayed there for 25 seconds. It stayed up here for 25 seconds. And then after it stayed for 25 seconds, it then traveled at a speed of 10 meters per second due south. We got 100 meters. So we got 100 meters, it come back down here, so now we know. And so it pass back X and it go to a point down here, so now, which is Z. So really and truly, it gone 40 meters past X in the opposite direction. This way. And this is where it was originally, upwards, right? So it passed X and go 40 meters, but it travel a distance of 100 meters south. Common sense, you know. And down here in this motion now, it go at a speed of 10 meters per second. That's what it said. 10 meters per second over here. 10 meters per second. Remember, as I said, speed equal distance over time when speed is constant. So time equal distance over speed. So if we want to know the time up here, we just need to divide the distance by the speed and get the time. And divide this distance, well, over here is 100 meters it went over here. And we put in 100 meters. It actually went 100 meters on this side. But it go 40 meters below. Go 40 meters below here. So 40 meters below where it started. All right? Question said we must calculate the average speed for the whole journey. So the average speed for the whole journey is a total distance over the total time. Because we're working out speed. Speed. Total distance over the total time. So all we need to do is find the time that you traveled up here and the time that you traveled down there. So let's break down the motion. Let's break it down. So let's break it down to get the total time. I will know that the average speed is the total distance over the total time. We already know the total distance, you know. It is 60 meters up and 100 meters down. So the total distance already is 160. But we need to know the total time, inclusive of the time that it stopped. Inclusive of the time that it stopped. So the distance is the journey from X to Y, let's call it XY. The time in that journey is the distance of 60 over the speed of 4. I already said speed equal distance over time. So time equal distance over speed. So we'll calculate that. That works out to what? 15?
Yes,
That's 15,
sir.
right? 15 and what? Seconds, meters per second. So that's 15 seconds. Then it stayed at Y. Stayed at Y. Let's call it T1, first part. At Y, it stayed there. Let's call it T2. It stayed there for 25 seconds. 25 seconds. It stayed there for 25 seconds. Covering no distance, right? 25 seconds. Then now it went from Y to Z. From Y to Z, T3, the third stanza, it traveled a distance of 100 meters. That's 100 meters, and it took 10 seconds. At 10 meters per second, so it took 10 seconds. 10 seconds. So the total time traveled is the sum of these. Total time. So let's write that out. Total time. Or we can just write the formula like this. Speed, average speed. Let's write it. Average speed equal total distance, actual distance traveled. Total actual distance over total actual time. Total distance is clearly, make it smaller. Let me select a smaller. Right. So the total actual distance is 160. 60 up and 100 down, don't it? 60 up plus 100 down. Total time is 15, 25, and 10. 15 to go, 25 to stay there, and 10 to come back. And that's what we're working on. Total distance over total time. Can somebody work that out for me, please?
Right.
3.2. 3.2 meters per second. That's the average speed. What's the magic with this question now? Not asking for the average velocity. Velocity. Remember now, velocity is displacement over time. Displacement over time. So it's for the whole journey, you know. Remember, it started here at X and ended up here at Z. So the displacement is actually negative 40. Because it's going negative 40, or if you want to specify, you can say it is 40 meters south. Because if you're giving the velocity, you have to give the direction. So it ended up 40 meters south, and it took us same total time to do it. Same total time. So it is the net displacement over the total time is average velocity. So we can say final displacement. Watch it now. Because it's velocity, we can say the average velocity equal, let's write it like this. It is the final displacement. Final displacement. Because it is displacement over time. Final displacement over the total time, for it to have that displacement over the total time. With all the up and down that it did, its final displacement was 40 meters south. And the time that it took was the same time like here, so. This is 40 and 10, that's 50, don't it? It's up to 50, agreed?
Yes, sir.
50 over 50. Where that out for me now? That's 4 over 5 or 8 over 10, which is 0.8 meters per second south. So I give the magnitude and the direction. But I understand that.
Yes, sir.
Yes, sir.
All right. So you get a question like that. Make sure you get it right. Velocity is displacement, final displacement over time. Speed is actual distance traveled over the actual time taken. The time is the same. 50 minutes was the time, total time. So for the speed, you're gonna add up all the distances that it actually did and divide it by the time. For the velocity, you just want to know what the final displacement is from where it started, and you give the direction. You have to give the direction because it asks for velocity. All right, that finishes that question. Boom, bang. 2019, remember we're going on to 2016, guys. I want to get as much work done as possible. So we're on to 2016. The next paper we're doing is 2019. 2019 is right here. If we can do question 6 today as well, that would be very nice. Question 6. And maybe we'll come back later and do some statistics and probability. Wow, time is going fast. Let's go. All right, see this question was a trouble question on the paper the year that I set it down. This question was a trouble question. This question, let me tell you what I mean by it was a trouble question. The trouble question in the sense that the solution that CSEC expected from this question was not aligned with the mark scheme that they gave. So I know that the solution that they expected was not what the current solution was. I don't even know if I want to do this question, right? I'm still gonna do some indication of it for you and show you, right? But I don't think I'm gonna work it all out to completion, right? And that's what they wanted. And I think we have to do some integration in this question as well. Right? We have to do some integration, and I think this is more integration question. This part of it is more integration question because this question is more integration question. What it is that they gave the stationary points, right? They gave us the 2 stationary points. Okay. If you notice, this value is higher than this value. So I would say that this one is a maximum one, and this one is a minimum one. I've used common sense to, Now this x value is less than this x value. So it means that the maximum came before the minimum. So therefore, the graph would shape like this. And this point would be the 315. And this point would be the 511 and 2/3. So this would be the minimum, this would be the maximum. By common sense. So this is the dy by dx I want, right? Now, we know that at a stationary point, dy by dx is equal to 0. At these 2 stationary points now, dy by dx is equal to 0. So we can say something like this. At the point where dy by dx equals 0, these are the 2 that we're getting from the equation that you would solve dy by dx equals 0. So it means that the equation, these will be the 2 x values at the point where dy by dx equals 0. So to get those 2 x values, you would have to solve an equation because these will be the roots. The roots from this equation are x equals 5, x equals 3, x equals 3, and x equals 5 are the 2 roots from this equation dy by dx equals 0. If you know the 2 roots, then you therefore also know the 2 factors that came out of this equation. What are the 2 factors? It will be x minus 3 and x minus 5. Those will be the 2 factors. Equals 0. So basically, this would have been your dy by dx now, but then there's a little trick to it now. You could have had a multiplying constant in front here as well. Could have had a multiplying constant inside here as well, over here. Because if this is an equation equals 0, when I divide by the a, I'll be left with this equals 0. I'm still going to get x equals 3 and x equals 5. I think CSEC did not consider that you could have a multiplying constant out there. And they wanted the solution just to be that. I don't think they consider the fact that you could have had a multiplying constant out here. I actually wrote CSEC about this question. I actually wrote them about it. And the reason I wrote them about it is because the amount of work that was required to solve this question the right way the mark scheme was not aligned with the amount of work required in the sections. And I wrote CSEC about this question, all right? Because this very last part is a lot of work because you ended up having two unknowns. You ended up having an unknown because when we have, this is dy by dx, and you really and truly you have to express it with the a in it, all right? And then when you integrate the dy by dx, you're gonna have the a and you're gonna have the constant of integration. So you're gonna have two unknowns. And to get two unknowns, you have to solve two equations. So you basically have to use these 2 points in the equation to find the two unknowns. And so this part of it, where they only gave 4 marks, it was too much work for 4 marks, relative to, for example, right here that they gave 5 marks, which was very easy because we could literally, to get the nature, we could literally look at the points that they gave and get the nature. Or having established this as our dy by dx. This is our dy by dx. You just needed to differentiate again, get the d2 by dx squared, right? And see which one positive and which one negative. So the 5 marks here was not aligned with the 4 marks here relative to the amount of work required. Want me to do it the right way? I want me to do it the way that CSEC expected. Tell me.
So the right way, please.
All right, let's do it the right way. So the right way, you have to imagine, you have to expect that you could have a multiplying constant here. So dy by dx would be equal to this. So you understand how I get this in the first place? Do you understand how I get this in the first place? As this being my dy by dx. Do you understand that?
Yes, sir. Yes,
Good.
sir.
Because if these are my stationary points, I know that at these stationary points, dy by dx is equal to 0. And they are basically telling me that at my stationary points where dy by dx equals 0, I'm getting these 2 x values. This point at this one, those 2 points. These are my x values at those 2 points. So these are the roots of this equation. And if these are the roots, then these are 2 factors from the equation. But then you can also have a multiplying constant in there that CSEC did not take into consideration when setting up this question. I'm sure. So I'm going to do it the right way. And I'm going to assume that the A is positive. Why would I assume that the A is positive? Can anybody tell me why I'm assuming that the A is positive? I'm assuming, because I have to assume that it is positive for the nature. And assume that the A is greater than 0. Why am I assuming that the A is positive? Somebody tell me.
So because the first stationary point is min?
No, because the first stationary point is a max. And when the first stationary point is a max,
Yes,
the
yes,
cubic
yes.
function, the cubic function will stay like this. Y equals ax cubed plus bx squared plus cx plus d. When the A is positive in your cubic function, your maximum comes first. And based on these values, this one has to be the maximum because it has a higher y value than this. And that's why I have to assume that my A is positive. This A is positive. It becomes very important, especially for when determining the nature. You understand that? All right? So that's why I'm telling you that this question, this question is not a reasonable question. They expected students to not put the A right there. All right, let's do it now. So I would expand this out. So this becomes my dy by dx. This becomes my dy by dx. This is my dy by dx. This. So to get my dy by dx, I just need to expand that out. Let's expand it out into separate terms. So to become equal to a into x squared minus 8x plus 15. That's what dy by dx would be. Which would then reduce to ax squared minus 8ax plus 15a. Assuming that a is a positive value. So this will be my dy by dx right there. All right? That's what the question asks to find out. Derive an expression for dy by dx. See here? This is it. If I left out the
So the one CSEC had deemed as correct didn't have the A in it?
Say that again?
So the one CSEC had as the correct answer didn't have A in it?
I don't know what they have as the correct answer. I'm telling you what the correct answer is. I'm telling you I'm telling you that based on the marks that they gave for these questions, based on the marks that they gave for the questions, because of the amount of work that is required here to get the equation, right? It could not have been that they expected students to put the a multiplying constant here. I'm telling you. I know they did not expect a solution that included a multiplying constant here, a possible multiplying constant. And it so happened that in this question, that multiplying constant actually had a value. I worked out the question and sent it to CSEC. I know they did not expect that solution. I just know it. Because if that is the case, if that's the solution that they expected, then the marks of 5 and the marks of 4 down here are not reasonable. They are not reasonable. I'm going to show you why. I'm going to show you. To get the 5 marks here, to get the nature, all I need to do now is differentiate this again to get the second derivative. Remember, I'm assuming that the a is positive enough. So I'm going to get my d2y by dx squared. And I'm going to get, boom, bang, 2ax minus 8a. That's what the d2y by dx squared is equal to. These are the two stationary points, x equals 3 and x equals 5. So I'm going to say at x equals 3, d2y by dx squared equals 2a times 3 minus 8a. See that? This is 6a minus 8a now. If you assume that the a is positive, then 6a minus 8a must be less than 0, don't it? Got to work out to be negative 2a, don't it? And if I assume that the a is a positive value, then this will be positive. So I'm saying that this is negative, and if that is negative, then we have a maximum at this point, which is true. So we can say, therefore, the point 3,5, 315 is a maximum. See there, 315 is a maximum, which you know already. So therefore, 315 is a maximum. And at x equals 5, the d2y by dx squared would be 2a times 5 minus 2a times 5, and x is 5. Remember, we're plugging it inside here, the 5. 2a times 5 minus 8a. Now this is 10a minus 8a. That is 2a. If the a is positive, then 2a is greater than 0. And when the second derivative is greater than 0, you have a minimum. So it means that the point 5 something, 5 this thing, 5 that thing, has to be a minimum. So we can say, therefore, 5, 11 and 2/3. Is 11 and 2/3? Yes, 5, 11 and 2/3 is a minimum. So quick we get 5 marks there. Easy, 5 marks. So say the killer here now. The killer now is to determine the equation of a curve. So I have to integrate to get the equation of a curve. Why? Because this is what we have. We have dy by dx equals this. So to get the equation of a curve, we're going to have to integrate this to get the y function. I know we're not doing integration yet, but I'm going to do it still. So we're on it already. Let's just finish it. So we're going to integrate this. All right? So we have the dy by dx. Let's write it out again. Let's copy it down. Let's copy it down because we're going to have to integrate to get the curve. All right? Let's copy this. Paste it here. And this is our dy by dx, right? This is our dy by dx that we have come up here. To get the curve, we have to integrate this. I integrate it without limits. And so when you integrate without limits, you have to put in a constant of integration. So you're going to have another unknown in the when we integrate it. So let's integrate this now. So when we integrate it, sorry about that. Where is it? So when we integrate this now, y is going to be, I don't even have enough space. I tell you, we don't have enough space to work this out. When I integrate it, the y is going to be equal to, integrate this one first. I add 1 to the power and divide by the new power. So I'm going to get 1/3. I'm going to get ax cubed over 3. Integrate this one. I'm going to get minus 8ax squared over 2. Integrate this one, I'm gonna get 15ax. But I have to add now a c for the constant of integration. To find the equation of a curve now, I have two unknowns. You know what that means? I have to get two equations. And therefore, I have to use the 2 points. I have to use the 2 points. The 315 to get one equation, and the 5, 11 and 2/3 to get the second equation. So much work needed to find the A and to find the C. I have to substitute these 2 points now to get two unknowns, A and C. Usually, if I did not have the A, I could just use one of them and find the C. Because there are two unknowns, I need two equations. And that is what the question is unreasonable. That is what the question is unreasonable. So this right here is the same as 33, this same as 35 over 3. So I'm going to write it as 5/35 over 3. So instead of using this, I'm going to use this. So let's cross this out. I'm going to use this point as this. All right? So it's two equations we need. So we're going to plug in the 315 first. So if we're using the 315, let's do it in red. Yes, do it in red. I'm using the 315 in this equation. I'm going to get 15 is the y value equals, I'm putting the 3 here, I'm going to get 27. I'm putting 3, I'm going to get 27. 27 over 3 is 9, so I'm going to get 9a minus, this becomes a 4 now. I'm putting the 3 here. Right? I'm putting the 3 here. 3 squared is 9. 9 4 is 36. I'm going to get 36a. I'm going to get minus 36a. Then I'm going to put the 3 right here now. 3 times 15 is 45. So I'm going to get 45a plus c. Consolidate these values. So consolidate these values. What is work out now? All of this add up to what? In terms of a. So 15 equals, add up this to me now. 3 minus 36 plus 4. What up? Minus 23 that?
Yes, sir.
Yes,
Minus
sir.
20. That's minus 23a plus c. That's the first equation. Then I have to use this point to get a second equation. See? Could never be that this value 4 marks. And then after I get the second equation, I have to solve them. Could never be that this value 4 marks. Could not. Relative to how we got the 5 marks up here. Far less work for 5 marks. And far less concentration, far less things to consider to get the 5 marks. So it could not be that this is a solution that they expected. But I'm doing it still, no problem. I'm going to use this point next. 35, no, 5, 35 over 3. That is the values friendly. Plug these values back in the equation again. I'm going to get 35 over 3 equals, I'm going to plug the 5 in there now. Let's zoom it up so we can see clearly. I'm going to plug the 5 inside here now. 5 cubed is 125. So this becomes 125a over 3 minus, remember this is 4 now, this is 4. 8 over 2 is 4. I'm plugging the 5 in there. That becomes 25. 5 squared is 25. 25 times 4 is 100. That's 100a. 100a. Then I'm going to plug the 5 here again for the x. 15 times 5 is how much? 75, don't it? 15 times 5 is 75.
Yes, sir.
Yes, sir.
I'm going to get plus 75a plus c. And then I need to work out all of these a's now. That's what I get. To make it simpler, I can multiply 2 by 3 first. I'm going to have to just work in the space down here now because, you know, that's it. We're going to have to work in the space down here to simplify this. We have enough space. Multiply 2 by 3. This becomes 35 equals 125a. This becomes, well, this and this becomes negative 25. These two become negative 25, right? Negative 25 multiplied by 3 becomes negative 75. So I'm going to get negative 75a and then plus 3c, If I multiply through by 3, I'm multiplying by 3 to go from this to this. multiply by 3 to get rid of these fractions and these fractions. Then I consolidate these values now. Let's consolidate. So this and this gives me what? 75, 125 minus 75 is how much? 75, right? No, not 75. How much is that?
50.
Yeah,
How
50.
much? 50. Okay, so I'm going to get 35 equals 50A plus 3C. So now I'm solving these two equations simultaneously. So let me hear this one and this one. Find the A and the C. See that? I'll solve those two simultaneously. So it kind of makes sense to multiply this one by 3 to get the 3C in both of them, right? I multiply that one by 3. So much work required for 5 marks could never be, for 4 marks could never be. So multiply this by 3, I'm going to get 45. Put it back in red. Put it back in red. Multiply this by 3, I get 45. Multiply this by 3, I get 69. Multiply this by 3, I get 3A, 3C. And so I am using these two equations now. These two. I'm going to subtract them. Let's subtract them. So let's do it like this. These two, when I subtract them, what am I going to get? Let's say I'm doing this one minus that one. Subtracting them. So 35 minus 45 is negative 10. 50 minus a negative 69 becomes 119. Tell me that is right. That's correct. That's correct.
Yes, sir.
119. And the 3C, we put the 3C that one, right? So the A equals negative 10 over 119. See them values there? That's what the A equals now. Then after the A equals negative 10 over 119, I'm going to drop back this negative 10 over 119 for the A right here to find the C. Right? So let's do that. So I can say and 35 equals 50 times minus 10 over 119 plus 3C. And find the C from this. Find the C from this. So the C would be equal to, it's just ridiculous. It is super ridiculous for 4 marks. Would never be. But you see, you have to find the C from that. Right? So this is called 35 plus whatever that is. Somebody can work this out for me, because when I bring this over this time, add it to 35. Tell me what to see and then divide by 3. Work it out for me. So you see these values that we're getting, guys. It is ridiculous. It doesn't make no sense. It just doesn't make any sense for 4 marks. It will never be. Tell me what you get. Work out the C for me. From here. Work it out. So we're going to transpose this over here and add it to 35. Let me do it. Let me do it over here. So I know this question was a error question by CSEC, and I just know. So it will be 35 plus fraction. 50 times 10 will be 500. Not that. Here. 500 over 119. All right. I want it as a fraction. I'm going to bracket this and bracket it over here. And because I have to divide by 3 to get the C, divided by 3. So I'm going to fraction that and put it over 3. That's what we're getting. Let's look at it as a final fraction. So it is this value. Look at that. That's what the C is now. So the C is equal to 4070 over 357. That's it. And then we can drop the A and the C in this now. That we get. Drop the A and the C in this now. Up here. We get the equation finally if we're doing it the right way. So you put the A and the C in this. That'll be it. Put the A and the C in there. If you want, you could factorize the A away from these. From these three. But I'm not even going any further. That's ridiculous. Just don't make no sense. But it's what I'm talking about, guys. Understand what I'm talking about?
Yes, sir.
Yes, sir.
Right. So I'm to do it the way that they expected now. I'm to do it the way that they expected. The way that they expected. The way they expected is with no A right there. And to be very simple. Let me just do it and show you what they expect. Even though it's an incorrect way. Let me just do it still. The way that they expected. Right? The way that whoever wrote the question, that's what they expected to happen. Which is not correct. Right? So I actually wrote CSEC about this question. I don't know if anybody else did, but I wrote them about it because it just didn't make any sense. They did not consider that you could have a multiplying constant. So they wanted you to put, since these are the two roots, they were saying, since these are the two roots, then these are just the two factors, right? And so the dy by dx would just be equal to that. If we expand it out, then the dy by dx will just work out to be 1 x squared minus 8x plus 15. That's what they expected, no a. All right? And then they want the nature now to get the nature of differentiates again. So you get d2y by dx squared would be equal to 2x minus 8. As easy as that. And then get the nature at x equals 3, d2y by dx squared will be equal to 2 times 3 minus 8, which will be less than 0. Therefore, the point 315 is a maximum point, and at x equals 5, d2y by dx squared will be 2 times 5 minus 8, which is now greater than 0. Answer the point 5. What is it again? 11 and 2/3. 11 and 2/3 would be a minimum, which will be true. And then here now they want to get the equation. So to get the equation now, we'll take this dy by dx and integrate it. That's what they wanted. That's what they expected the solution to be. Whoever wrote the question. All right. They did not consider fully that it could have a multiplying constant. And it was inconsistent with the stationary point that they give actually. Inconsistent, because I showed you what a correct solution is. Right? So you have this, and you want the dy by dx, and so you have to integrate, right? So the y, you have to integrate this now to get the dy by, to get the y, sorry, to get the curve, right? You have to integrate. So you have that as a dy by dx, and so the y will be equal to the integral of x squared minus 8x plus 15 with respect to x, and so the y will be equal to x cubed over 3 minus, this will become 4x squared, this one if you integrate it, plus 15x plus c. And if you find this c, you know, just use a 0.35, for example. So if we say at 315, sorry, you plug them in there to find the c value, and you will get 15 equals, this will become 3 cubed over 3, that's 27 over 3, which is 9 minus, this will become 9. 9 4 is 36, so subtracting 36, plus this will become 3 times 15 times 3, which is 45, plus c. And then from this now you could write the c. You know what c equals. So to consolidate these and put it over here. What is that? What would that be? What would that be? Pick up for us.
-3.
So c will be -3. Thanks for that. So the c will be -3. And so the equation here now would simply become y equals x cubed over 3 minus 4x squared plus 15x minus 3. That is what they expected. See, 4 marks to be more reasonable now. That's what they expected. Right? But this is inconsistent with the points. But if you differentiate but this now, to find the stationary points, it's not going to give you those 2 stationary points that they gave you. So it's inconsistent. I just showed you what the correct thing is. So that was a boo-boo question on CXC's part. What it happens. All right? So that is that. So we're still on this differentiation question. So let's go now. Spend a lot of time on this one, but that's what it is sometimes. They want us now to differentiate this guy. We need to write this as a power function. You need to write that as a power function, guys. Write it as a power of x. Don't try to differentiate with the root. And this is actually cube root. So as a power function, this could be written as y equals 2x plus 3. This is the power and the 3 is the root. Let me if you know this now. It is equal to the 2/3 is the power. But I get that?
Yes, sir.
Yes, sir.
Good. And here is the power. What here is the root. Root goes on the denominator. Right? So this is the power up top, and on the denominator is the root, cube root. That's what we're differentiating. So it's a function of a function. The dy by dx equals, I will do it act as if you're differentiating an x to the 2/3 first. So it becomes 2/3, 2x plus 3. So you differentiate the whole thing, reduce this power by 1. So like you're subtracting 3/3. So it becomes negative 1/3. You subtract the 3/3. So reduce the power by 1. Then you multiply by the differential of what's inside here. Differentiate and put it out here. That's a 2. You differentiate in here, you're going to get a 2. That's it. So if you consolidate the values now, simplify it, it becomes equal to. This 2 times this 2 is 4. This negative 1 means reciprocal enough. Remember, the cube is 3. Root is a cube, right? Cube root. So I'm going to put 4 over this 3. Then this is going to come under here. That's what the minus 4 will do. And it's a cube root. So it becomes a cube root of 2x plus 3. And that is my final answer. But I go to that.
Yes, sir.
Yes, sir.
All right. Beautiful. Question done. All right. Let's go. Let's go to 2018. This spent a lot of time on that question, but so it go. More maths equals better maths anyway. So let's go. 2018. 2018 is right here. 2018. All right. So we're at question 5, differentiation again. All right, right here. That's a cubic function. You can see it. Cubic function again. It's not good. This is positive, so it's going to shape like that. So the max is going to come for the min. So the max is going to have the lower x value, smaller x value at the stationary points. Coordinates of the stationary points. And the next, they're going to ask us for the nature as well. The nature of the stationary point. So because they ask me for the nature, I'm just going to do the second derivative. As I know, I need a second derivative for the nature. So let's go. So I need a gradient function first. Dy by dx is a gradient function. Differentiate it. Comes 3x squared, bam, plus 4x. And for the nature, I need a second derivative. d2y by dx squared equals, I'm differentiating this again, becomes 6x plus 4. 6x plus 4. At the stationary point, dy by dx equals 0. Let's say that at the stationary points, dy by dx, the gradient is equal to 0 at the stationary point. So putting this equals 0. That is 3x squared plus 4x equals 0. That's 2 terms to factorize, only 2 terms. Even though it's quadratic, it's only 2 terms. You pull out the common factor. So the common factor is x into 3x plus 4 equals 0. So it's leading me, this is leading me to x equals 0 from this factor, x equals 0. From this factor, x equals negative 3/4. X equals negative 4/3. 4/3, I should say. So those are the 2 x values. I need to find a y value to go with this and a y value to go with that. How do I get them? Plug them back. Plug them back. Where am I? Plug them back into the original function to get the corresponding y values. Let's go. So at x equals, let's do a different color. Let's do a different color. At x equals 0, y equals plug 0 inside here. I'm going to get negative 1. Negative 1. Easy. So one stationary point is 0, negative 1. The other stationary point is where x equals negative 4/3. Plug the negative 4/3 inside here. So the y is going to be negative 4/3 cubed. Work out the calculator for me, please. Plus 2 times negative 4/3 squared minus 1. Just drop it in the calculator and tell me what you get. Y equals what? What is that? Just put this in the calculator for me, please, and tell me what I get as a fraction.
Negative 59 over 27.
Negative how much?
59 over 27.
Negative 59 over 27. So it means that the second point is negative 4/3, 59 over 27. I don't know 6, you have to give these by, but that is it. And based on our sketch, this is the one with a smaller value. So this is one is going to be our max. Makes sense too, because that y value is higher than that. This one is going to be our max. And this one is going to be our min. We know that already, but they want us to show it. And we show it with the second derivative. To get the nature, we use the second derivative. d2y by dx squared, we calculate it up here as 6x plus 4. 6x plus 4. 6x plus 4. At x equals 0, one of them was 0, right? Bam. At x equals 0, the d2y by dx squared is 6 times 0 plus 4, which is greater than 0. Therefore, that's a minimum. Therefore, we have a minimum. Therefore, 0, negative 1 is negative 1 is a minimum. Is a minimum point. You have to write out the point, you know, say is a minimum point. And the other one is at, let's shift this up a bit. Let me shift this up a bit. Let me shift this up. Let's shift this up here, like that. Let's shift it like that. Right. The second one now is at x equal, what is it again? That value there, negative 4/3. The d2y by dx squared is 6 times negative 4/3 plus 4. That's going to work out to be a negative value. Don't need to know the value. Just know that it's going to come out negative. One is negative. Because if I put this as something over 3, it is 12/3. And this is negative 24/3. So it must come out negative, right? I don't have to work with the actual value. I just need to know that it's negative. Therefore, the point, negative 4/3, what is it again? Some weird value, 59/27. 59/27 is a maximum point. Is a maximum point, and that is it. Very good? That's it. Very good at that? All right, beautiful. Then we're going to differentiate this guy right here now. That's a product. We're going to work with the root. Write this as a power function, right? As a power. So I'm first write it as y equals 2x times 4 minus 8x to the power half. Write it as a power function. Don't work with the root. You want to see the power. The power is a half. You want to differentiate it as a product using the product rule. This is the first and this is the second. Don't need to write no UV business. Don't need to write it. All you need to do is keep the first and differentiate the second, plus keep the second and differentiate the first. All you need to do. So dy by dx equals, keep the first, keeping the first. I'm going to differentiate that. I know it's a composite. I'm going to put it in a square bracket and differentiate it in there. First, I differentiate it as if it is x to the half. As a composite, so it becomes half, put back the whole thing, 4 minus 8x, reduces power by 1. So you subtract 1, which is 2/2. So you get minus half. 1 minus 2 is negative 1. So you get minus half. Half minus 1 is negative half. You have to remember to differentiate what's inside the bracket. Differentiate what's inside the bracket here. a composite. So you multiply by the differential of what's in it, which is a -8. You differentiate inside, you get -8. That's what I've done first. Let's shift this over. I need some more space. What I've done so far is I've kept the first and differentiated the second. That's all I've done so far. Kept the first and differentiate the second. Plus, I have to now keep the second and differentiate the first. I'm going to write down the second, which is 4 minus 8x to the half. And I have to multiply by the differential of the first, which is 2. Differential of the first is 2. But understand that?
Yes.
What
Yes,
about?
sir.
Then all I need to do now is simplify, right? Careful the simplification now. I'm gonna simplify. Ready now? Boom, bang. This one first. This 2 cancels this half, right? So therefore, I'm working with this -8x. Negative 8x I have. -8x. I write it from now. -8x. I write because I know that this -4 is gonna put me on the denominator. And it's a square root because the half power is square root of 4 minus 8x. But go to that. The first one.
Yes, sir.
And then over here now, it's simply 2 times the square root of 4 minus 8x. That's a positive half, you know, so it remains there. And this 2 is multiplying by. That is it. Nice and easy. Very good?
Yes, sir.
Very good with that. Remember, if you don't understand something, talk, you know. Everybody in here bright. I don't want nobody asking any question. No problem. Let's go. It's revision. 2017. 2017 next. Let's go. 2017. 2017. Let's go. Let's go. Let's go. Where are you? 2017 is right here. 2017. All right. So looking at the differentiation question number 4 or 5. We don't know number 4 already. Number 4 was this, that was a trick. It's ready right here. More of the same, guys. More of the same. This question says we are to differentiate this thing. That's a product. This part of it is a composite. So when you're ready to differentiate this part of it, you have to differentiate it as it is, a composite. When you use a product tool on it, simple. Don't need no UV business. You don't have time and space for that. Don't need no extra writing. dy by dx, you can call it that, equals. Keep the first, differentiate the second. Keep the first, 1 plus 2x cubed. Differentiate this. When you differentiate this, you get 1. You still have to show it. Even though it is 1, it's not going to change anything. You still have to show it. Plus, keep the second thing, which is the x plus 3. They're going to differentiate the first. Because that's a composite, I'm going to put it in a square bracket to differentiate it in there. First, to differentiate it as if it is x cubed. So that will be 3 times the whole thing. 1 plus 2x. Reduce the power by 1 to 2. And you have to remember to differentiate what's inside here, out here. Differentiate it. We differentiate what's in the bracket, we're going to get that 2. But go to that.
Yes, sir.
Yes, sir.
Then we're going to simplify. 1 times this is just remains the same. 1 plus 2x cubed. Careful these now. This 2, 3 times 2 is 6. 6 in front of this. X plus 3 in front of this. 1 plus 2x squared. That's it. Done. If you want, it's a simplified answer. So if you want, I can factorize this and this. Factorize those 2. Let's go. When I'm saying simplify, I'm going to factorize them, right? So I'm going to factorize this and this. Factorize out those 2. As factor between this and this is actually this one, the square. So I'm factoring out this out of these 2 terms. Ready? Careful now. It is 1 plus 2x squared. Factored out of this leaves me with a 1 plus 2x. Factored out of this factored out of this leaves me with this. I'm going to write what it is. It is 6x plus 18. 6 is 18. So I'm going to write plus 6x plus 18. inside there. So as a last line, I get 1 plus 2x squared into this, and this is 8x. 8x, 1 and 18 is 19. And I'm going to leave it there. Overstay. Everybody good?
Yes, sir.
Yes, sir.
All right, good. Next question says, this point lies on this curve. Determine the equation of the normal to the curve. Differentiation, you know. Remember, I told you yesterday that when you're doing circles, the normal is your best friend. When you're doing curves, the tangent is your best friend. The tangent helps you find the normal. Why is that? Because the curve and the tangent have the same gradient. The gradient of a curve is equal to the gradient of a tangent at the point of tangent at this point. So when you differentiate the curve, you're also getting, when you get the gradient function for the curve, that also is a gradient for the tangent at any point on the curve. Let's go. So we're going to get the tangent first. So see, you know, the gradient of the tangent is the dy by dx at the point where x is -2, where x equals -2. Not 2, -2, which is equal to, we're going to differentiate this now. And we're going to put -2 in there, and that's going to give us gradient of a tangent. The tangent and the curve have the same gradient. That's why the tangent is your better friend when you have curves. The tangent helps you find the normal. They are perpendicular still. We're differentiating this to get the gradient function. Differentiate this one, we're going to get 9x squared. Differentiate this one, I'm going to get 4x. Differentiate this one, I'm going to get -24. That is my gradient function. To get the gradient of a tangent, I need to substitute the -2 in there. So the gradient of my tangent, I'm going to put the -2 in there, is 9 times -2 squared plus 4 times -2 minus 24. Let me shift this over. Somebody work it out for me and I just put it on the right side here. Shift this over here. What is work out to? Gradient of my tangent. Work it out for me. What is that?
4.
4? 4.
Yes, sir.
So if that's the gradient of a tangent, it means therefore that the gradient of my normal is -1 over the gradient of a tangent, which is -1/4. Just check the 4 and drop it under here for the tangent. Always so flip this 4 and change the sign. 4 is the same as 4/1. Flip it and change the sign to become -1/4. Anyway you want to look at it, that is the gradient of a tangent. That's the gradient of the normal. So we're using this normal and this point to find the equation of the normal. That gradient and that point. So the normal becomes, see you know, the normal is y minus the y value at the point is 0. The gradient of the normal is -1/4 into x minus the x value at the point is -2. Minus becomes a +2. But I go to that. This is just 0, you know. So I can just expand out these terms and write y equals -1/4 x minus half. This under here is my answer. So I have to be writing it down here, but this right here is my answer. This is the answer right here. That's the answer. Better go to that?
Yes, sir.
Yes, sir.
All right. Don't get these questions wrong in the exam, you know, they're too easy. Don't get them wrong. Get any question like this on the paper, shut it up. Don't get it wrong. Next part. This question now is what we call a connected rates of change question. Connected rates of change, all right? It's an application question. Different teachers call it different, right? It's a connected rates of change. We're going to connect the rates of change using the chain rule. Use the chain rule to connect the rates of change, to find rates of change that we don't have. It says, water is poured into a container of radius 15. So this is constant, you know, this radius is 15, R equals 15. That's a constant value, it's not going to change. So the radius is not changing, it's a constant. It says the height of water increased at a rate of 2 meters per second. The height of water in the container, it's a cylindrical container, you know. It's a cylinder, right? It's a cylinder. So since it is cylindrical, all the formulae relating to a cylinder valid on it. For example, volume equals pi r squared h. Remember, the r is a constant. The r is not changing. So the height is changing, so the volume will change. This is a constant, but be careful. You cannot differentiate with respect to a constant. You differentiate with respect to variables, things that are changing. So right now, you can only differentiate dV by dH, because these are what are changing. You don't differentiate with respect to a constant. The radius is a constant, it's not changing. All right, let's continue. So what is it that they just gave us? What is this that they just gave us that I have underlined? What is this? Question told us this. It told us that the height of water increases at a rate of 2 centimeters per second. What is that information they just gave us? What is that? How can we write that as a mathematical expression? The height of water increases at a rate of 2 meters per second. What is that? Anybody? It's a rate of change of the height. Look, the height is in centimeters. It's a rate of 2 meters per second. Per second means with respect to time. Time is always changing. So what that expression underlined means is that dH by dt is equal to 2. That's what they just gave us, the rate of change of the height of the water. That's what they just gave us. It's changed at a constant rate of 2 meters per second. What if they had said it was decreasing at a rate of 2 meters per second? What would they put? The height is decreasing at a rate of 2. You have to put minus if it was a decrease. dH by dt will be -2 because it is decreasing. Okay, decreasing. Increasing functions of positive gradient, decreasing functions of negative gradient. Mute the mic, please. Mute the mic, please. So this is a positive 2 that gave us. Mute your mic, please. Mute your mic, please. All right, so let's see. Ooh, mic is open. All right, so the mic sound closed. All right, cool. So they just gave us this, right? And look now. So they gave us that I have underlined. Let me remove this now. I'm going to ask you something else. Question says, given that the formula for the volume is pi r squared h, and that's what I wrote here. The volume is pi r squared h, and we should know that. So they gave us that. The volume is pi r squared h, right? The question says no. Determine the rate of increase of the volume of the container in terms of pi. Determine the rate of increase of the volume of the container in terms of pi. What is this asking us to find? What is that? Determine the rate of increase of the volume in the container in terms of pi. Meaning pi must be an answer. What is that asking us to find? Somebody tell me. What is that asking us for? V is volume, H is height, T is time. What is this asking us to find? Somebody tell me.
dV over dt.
dV dt.
Good. It's asking me for dV by dt. Beautiful. That's what it's asking me to find. Remember, I don't have any direct relationship between V and T. I don't have any formula connecting V and T. So therefore, I have to find dV by dt by connecting rates of change that I have. Because I have this relationship, I can differentiate and find dV by dH. But remember, as I said, the R is a constant. And in fact, because the R is 15, I can work out what V is in terms of H right here. So the V becomes equal to pi times 15 squared times H. 15 squared is how much? 15 squared is how much?
225.
225. So the V equals 225 pi H. So I can differentiate the V with respect to H and get dV by dH is just 225 pi. Watch me now. I want to find this guy here. So I want to find that. This is what I'm trying to find. Sit here to find this. This is what the question wants me to find this. I have to use a chain rule. Let's put it right here. I'm going to find it in this box. I have to use a chain rule to find it. dv by dt is what I want. I don't have any formula connecting the v and the t. The rate of change that I have that I can connect are this one and this one. Those are two rates of change that I can connect to get this. If you have rate of change of height with respect to time, then you have the rate of change of v with respect to height. Then you can connect these two and find that one. And you connect them with the chain rule. How you set up this chain rule now? Pay attention to the details, everything important. This becomes equal to the product of two rates of change. That's only two rates of change you have. I have to position them the right way. The numerator on this one goes on the numerator of the first one, which is the dv. So the dv goes here. The dt goes on the denominator of the second one. The dt goes under here. Set it up properly. The third variable, which is the h, goes here and here, as if they want to cancel each other. But that's how you set it up. So to get this result, we have to multiply the dv by dh, which is just this, with the dh by dt, which is just that. And so it's fairly simple and straightforward. Sometimes you have to take some reciprocal for some of them. But this is it. dv by dt becomes then equal to 225 pi. That's what this is. Times the 2, which is what this is. Times the 2. And so the answer becomes 2 times this is how much? I must leave it in terms of 450 pi. 450 pi. And what's my unit? I have to give a unit, you know. What's the unit of this? What's the unit?
Centimeter cube per second.
Good. cm cube per second. Beautiful. Because remember, the volume is cm cube and the volume is cm cube and the time is second. If you don't put the unit, you can lose a mark. So it's cm cube per second. S to the minus 1. Did they give us that s to the minus 1 up here? Yes. So we're going to use that as same notation. That is it. Everybody go to that? Easy question.
Yes,
I love it. I love it. Easy question. That is it. All right. Rates of change. That's the first one since we started. Anything else? No. Question done. 2016 now. 2016. Let's go. 2016. Hopefully another rate of change than 2016. Because we don't do any other one yet. It's just one alone we do for the day, right? 2016. Connected rates of change. 2016. All right. We're not going to do any past this 2016, but if we finish all the questions of 2016 for all the topics, we still have time. We're going to go back and work from 2015 down, all right? Just to try and cover all the bases. I know a lot of you are buyer tomorrow, but we still want to get as much work done as we can. All right, ready now? This 2016 question says we are to find dy by dx of this. Write it as a power function. Write it as a power function so you can see the power. Right? So I'm going to write it as y equals 5x squared minus 4 to the power half. Square root is to the power half. Then I'm going to differentiate it right here. dy by dx equals, let's write it on this line, dy by dx equals. Differentiate first as if it is x to the half, it's a composite. Differentiate it first as if it is x to the half. So I'm going to get a half bracket, put by the whole thing, 5x squared minus 4, reduce this power by 1. Half minus 1 is negative half. Let me shift this down. Shift this down. I don't want it too close to that. Let's put it here. So the minus half. Then you have to multiply by the differential of what's in the bracket out here. We differentiate what's in the bracket, we're going to get 10x. So multiply by 10x. Multiply by the 10x, which is the differential of what's in the bracket. Want to go to that?
Yes, sir.
Let's just simplify. So let's simplify now. Half of the 10x is 5x. This negative 4 is going to put me under the denominator. So I'm going to write, let's put it right here on the line. Let's put it on the line right here. Equals. Let's put it on the line. So I'm going to put 5x up here. Half of the 10x is 5x. This power, negative 4, is going to put me on the denominator, and it's power half, so it's square root. I'm going to put the square root of the 5x squared minus 4. And basically, that is it. This is the answer. Very good. 2 marks for that.
Yes, sir.
Yes, sir.
2 marks for that. Don't get it wrong in the exam, please. This question says, it's another normal question here again. Ask you for normal again. The point P is like a repeat, lies on this curve. Determine the equation of the normal at P. Same question I would just did a while ago. What's this now? This I would have to use product rule to differentiate it now. I'd have to use the product rule to differentiate it. So we can differentiate and use the product rule if I want, and all of that. But when it can be expanded out into separate terms, I'm going to do that. Just expand it out into separate terms and differentiate it term by term. So I'm going to write this as y equals 2x into x squared plus 2x plus 1. And so y equals, expand this 2x over here now, becomes 2x cubed plus 4x squared plus 2x. I'm going to work with this and differentiate it. So the gradient of my tangent is dy by dx. Remember, the tangent helps to find the normal. And I'm working at the point where x equals 1, at the point where x equals 1, at x equals 1, tangent at x equals 1. This is the gradient of the differentiate. So becomes, this is the function of the differentiate to get the gradient. I'll get 6x squared plus 8x plus 2. Then I have to plug the 1 in there. Let's shift it over and plug the 1 in there one time. Let's plug the 1 in there one time. And when it's 1 I plug in there, it's not going to change any of these values. So this will remain 6 when I plug 1 in there. This will remain 8 when I plug the 1 in there. And this will remain 2. This is just 2. That becomes 16, don't it? 16. That's the gradient of a tangent. It's 16. Therefore, the gradient of my normal is minus 1 over the gradient of the tangent, which is negative 1 over 16. So I'm going to use now this normal gradient at this point to find the equation of my normal. Let's do it in red now. So the normal becomes, the normal is y minus the y value at the point is 8. Y minus 8 equals the gradient of the normal is negative 1 over 16 into x minus the x value at the point is 1. That's the normal. That's the equation of a normal. Just expand it out now or simplify it. All right? So we can just multiply across, we can multiply this inside there, or we can simplify by multiplying the 16 over this side. So the 16 times 8 is how much?
129 on 16.
So I'm going to multiply the 16 over here. I'm going to get 16y minus how much I say?
129.
16 times 8 is 128.
Sorry, 128. Yes, sorry.
Good. Equals, I'm going to multiply the negative 1 inside here now. I'm going to get minus x plus 1. And you're getting the 129 because they're transferring and adding to that, right? So 16y equals minus x plus the 129 you're talking about. And that is my answer. That's my tangent line. 5 marks for that. Don't give it away. Make sure you get it if they ask you one like that on the exam tomorrow, Tuesday. Anything else? Let's see this one. This one says, obtain the equation of each of the 2 tangents drawn on this curve at the point where y equals 16. That's a quadratic curve, you know. That's the first quadratic curve, you know. So if we were to sketch it, let's sketch it right here. See what we're talking about. So like you have the quadratic curve. Let's look at it so we can visualize. And the quadratic curve is this. Let's draw it in curve. Bam. That's a quadratic curve, x squared. That's x squared curve, right? y equals x squared. At the point where y equals 16, let's say it is here, let's put on in red. 16 is this point, and this point. At y equals 16, at the y equals 16, clearly the x value is 4. That's 416. And this point is negative 416. Negative 416. This one is negative 416. And I shift it over. This one is negative 4. Sorry about that. Negative 416. Those are the 2 points where y equals 16. Everybody can agree with that?
Yes, sir.
Yes, sir.
So this is the y value is the y value is 16. So the two x values when y is 16 is 4 and negative 4. So we're trying to find the two tangents at negative 416 and 416. All right, so let's show this some work. Let's show some. So at y equals 16, it means that x squared is equal to 16, and so x is equal to plus or minus 4. So the 2 points we're talking about is 416 and negative 416. So these are the 2 points where we want to find the tangents. We want to find the equation of a tangent, we need the gradient of a tangent. And these are the two tangents. Let me draw the two tangents anyway. So this is one tangent down here, so. And this is the other tangent down here, so. And this graph is perfect symmetrical enough. So two tangents gonna meet at the same point down here. I bet you, I can tell you that. They're gonna meet somewhere down here. Those two tangents gonna meet at the same point. Right? I think they're gonna meet on the y-axis based on this sketch. Two tangents are gonna meet down here on the y-axis someplace. But the graph is a symmetrical graph. The positive graph is a symmetrical graph. Those are my two tangents that I'm trying to find. All right, so already know. So I'm gonna search for the two tangents. First, I need the gradient of them. I need the gradient of the two tangents. The gradient of my tangent is dy by dx. So I'm differentiating this x squared, I get 2x. That's my gradient function, right? So at the first point, 416. So I can say at 416, the gradient of my tangent at that point is 2 times 4. 2 times 4, which is 8. So I'm using this point and this gradient to find that tangent, the first one. So I can write y minus, let's put that in red. That first tangent, let's call it tangent 1. Tangent 1, using this point and this gradient, is y minus the y value here is 16, equal to gradient of a tangent is 8, into x minus the x value at that point is 4. That gives me that tangent, you know. So it's y minus 16 equals 8x minus how much? 32. It was 32. Yeah. This 16 come over here and add to that, give me negative 16. So it's y equals 8x minus 16. You can bet the next one is going to be y equals minus 8x minus 16. The graph symmetrical. This graph have a grade of negative 8. You can see it. It's obvious enough because this point down is negative 16. Eh? So if this to this has a grade of 8, then this to this must have a grade of negative 8. And have a same y-axis intercept. Same y-axis intercept. Well, let's work it out. Let's work it out. All right, so this is the first one. That's the first one we found. The second one, tangent 2. Tangent 2 is at x equals, so it's at the point negative 416. The second one. The grade of a tangent at that point is 2 times negative 4, see? Which is negative 8. So this is the point, and this is the gradient. So tangent 2 now, we reason it out and say it is just with the negative 8 gradient and say negative 16 y-axis intercept. But tangent 8, tangent 2 becomes y minus y value at the point is 16 again, equals the gradient now is negative 8 into negative 8 into x minus x value at the point is negative 2. Minus minus becomes a negative 4, I mean. Minus minus becomes a plus 4. To expand this out, we're gonna get y minus 16 equals negative 8x minus 32 again. Minus 32 again. See? Minus 32. This comes over and give me plus 32. So I get y equals minus 8x minus 16 again. So these are the two tangents right here. This is the first tangent. See? That's one answer. And this is the second one. So I haven't found the first one. I could have reasoned out the second one. All right? Because the quadratic graph is a symmetrical graph. So the two tangents are like symmetrical about the y-axis. But that's it. But good.
Yes, sir.
Yes, sir.
All right. So we're gonna take a 10 minutes break and then we'll come back and we're gonna do the integration questions. The next question on the paper. This is the number 6 question. We're gonna integrate next. Okay? 10 minutes break. So it's now 2:22 on the screen. Let me put up the timer. Let me put up the timer. I'm gonna take a 10 minutes break or a 30 minutes break. Let's see. Put up the timer. I'm gonna put it up for 30 minutes. Let's put it up for 30 minutes. 30. More than 10 minutes. Start. Okay? 30 minutes break. Everybody good?
Yes, sir.
Yes, sir.
All right. So get something to eat, stretch your legs, drink some water, some juice. And come back, I'm gonna run through some integration. All right. Maybe we'll have a session tonight so we can do probability and statistics, one of them. And so tomorrow we have less stuff to do. Still have the inequalities to do, which is very easy. And we still have the linear reduction graph ones to do. All right. Let's see if we can get through everything, guys. Let's see. Let's do our best. And we have biology. So let's see what we can do. All right. Let's see what we can do. Okay, guys, ready again?
Yes, sir.
Hello? All right.
Yes, sir.
So we're gonna try and run through the integration, and hopefully we will have sufficient time to do probability and or statistics. All right. So let us see what we can do. Let us see what we can do. All right. So it's integration time. And integration is simply the reverse process of differentiation. So if you know how to integrate, then you will know how, if you know how to differentiate, you will know how to integrate. You're reversing the process. Just that integration also has some application that you can use an integration method to find area under a curve, and also we can use integration to find volume of revolution. And integration also is used in kinematics to the reverse of differentiation. Because you differentiate, for example, displacement to get velocity, and differentiate velocity to get acceleration. And so you have to integrate acceleration to get velocity, and then integrate velocity to get displacement. All right, so I come up on some of those questions, especially in the more recent papers. All right, so this first one on the screen is supposed to integrate those trigs. Now, when I'm integrating trigs, I always try to remember what I differentiated. And oftentimes, when you get your answer from integration, what you can do is differentiate it again to see if you will get back what you integrated. Another thing, let us not forget to put the constant of integration when we integrate without limits. Because when you integrate without limits, you are finding a family of curves. All right? So you have to put in the constant of integration to represent that family of curves. All right, so ready now. So I want to integrate this. So I want to integrate cos. Remember, when I differentiate sine, I get cos. So if I integrate cos, I get sine. So the integration of this is just simply 3 sine theta. Then I'm going to integrate this sine. When I differentiate cos, I get minus sine. This is actually minus already. When I differentiate cos, I get minus sine. So when I integrate sine, I'm going to get back minus cos. So it means that this must have been a plus 5 cos x, cos theta, I should say. Cos theta plus c. And if you're not sure, all you have to do is differentiate this again and see if you get back that. If I differentiate this, I'm going to get back this, which is good. If I differentiate this, I'm going to get back this with the negative, which is good. And if I differentiate the constant, I'm going to get 0. So this is my answer. But good at that?
Yes, sir.
Yes, sir.
All right, good. Always double check. Differentiate, integration, try to double check it when you can. Next question. We want us to integrate this between these two limits. So we're going to get a value now. So at this level, we want to integrate powers of x. So you see this x squared under here? I'm going to write it as x to the minus 2. I'm going to bring it up and write it as x to the minus 2. And when you integrate at this level, you also want to expand out your terms, expand out into separate terms where necessary or where possible, because at this level, you have not yet learned how to integrate fractions. Integration of fractions is a big topic, is a topic in itself in integration that is taught at unit 2 and some of it at unit 1, pure maths. But at this level, you're really integrating term by term. So if you give you something complicated to integrate, seek to expand it out into separate terms and integrate it term by term, or seek to bring it to some power, x to some single power, and integrate it that way. Simplify. That is the extent of your syllabus right now. So this, I'm going to write this as the integral from 1 to 3. This I'm going to write it as 2x to the negative 2. This is still negative 3. And this is plus 2x cubed. And don't forget to put your dates. You have to integrate with respect to something. Then we are able to integrate this term by term. So this is now equal to. I'm going to put my square brackets because I'm going to put my limits on my square brackets. I'm integrating this now. How do we do it? Add 1 to the power, divide by the new power. When I add 1 to this negative 2, it becomes negative 1. So it becomes 2x to the minus 1 divided by the new power of minus 1. When you integrate 3x, when you integrate 3, you're going to get 3x. I'm going to get minus 3x. Why is that? Because 3x is the same as 3 times x to the 0. Add 1 to the power, you get x to the 1 and divide by the new power, which is 1. That's so theoretically, it's still following the basic principle. Then when I integrate this thing, I'm going to add 1 to the power. So I'm going to get 2x to the 4th power, divided by the new power of 4. And I'm integrating between the limits of 3 and 1, from 1 to 3. If you want, you can simplify first before you apply the limits. So I can go and write this as, this is the same as, we tend not to work with negative powers, okay guys? Don't work with negative powers. This 2 over negative 1 is negative 2. So this is negative 2 over x minus 3x. This simplifies down to x to the 4th power over 2. And you're going between 3 and 1. So far, so good? So far, so good?
Yes,
Yes,
sir.
sir.
Then I'm going to put in the 3 in there first in one bracket. Put in the 3. So it's minus 2 over 3. Minus 3 times 3. Plus 3 to the 4th power over 2 in the first bracket. Minus, I'm going to put in the 1 now. Bracket. Put in the 1 here, I'm going to get negative 2. Put in the 1 here, I'm going to get negative 3. Put in the 1 here, I'm going to get a half. What are good with that?
Yes,
Put
sir.
all of that in the calculator. Put all of that in the calculator and work it out. Put all of that in the calculator. Just as it is there, work it out and write your answer. Use the full capabilities of your calculator. Move fast. What is that equal to? Somebody work it out for me. And be careful with these negatives. That's why you put it in the calculator exact as it is. Let me see. I'm going to use my calculator. Put it in there. I'm going to put my bracket. Sorry. Negative 2 over 3 minus, that's 9, plus 3 raised to the power 4 over, no, not there, not there, not there, over 2, close bracket, minus, open bracket, negative 2 and the negative 3, there's negative 5, plus half, close bracket, not there. And I'm getting 35.3. If I look at it as a fraction to get the exact value, it is this 106 over 3. 106 over 3. Anybody got that as well? Anybody got that as well? All right, nobody else doing it. That is the answer. All right, nobody doing it. All right, no problem. Let me do it. Let me do it. Next question. The following figure shows the finite region R bounded by the lines x equals 1, x equals 2, and this curve. So this is that curve. Find the area under the curve, or the area under here. So to find that area, remember, area is the integral of y dx, and y is the equation of a curve between the limits 1 and 2. Between 1 and 2. This is the y. I see it's a composite function there. I'm going to expand it out into separate terms and keep it simple. So this, I'm going to expand it out into separate terms. I'm going to write y equals x squared minus 4x plus 4 and plus 5, that's plus 9. That's what I'm going to integrate. Separate terms. Instead of having to work with that composite function there, span it out into separate terms when you can. So I'm going to do this now. That area is equal to the integral of x squared minus 4x plus 9. Don't forget to put your dx. You must integrate with respect to something between the limits of 1 and 2. All right, let's go now. A equals, put them in the square bracket. The integral of x squared is x cubed over 3. Integral of 4x is minus 2x squared. But I agree with that. Add 1 to the power, divide by a new power. That's what I'm going to get. The integral of 9 is 9x between the limits of 2 and 1. More of the same. But okay there?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Area equal. Plug in the 2 first. I'm going to get 2 cubed is 8 over 3. Plug in the 2 here. I'm going to get 2 times 4 is 8. Plug in the 2 here. I'm going to get 9 times 2 is 18 in the first bracket. Minus. Second bracket, I'm plugging in the 1. 1 cubed is 1. I'm going to get a third. Minus. 2 times 1 here is just 2. Plus 9 times 1 here is just 9. Put all of that in the calculator again. When you get the area, you have to say units squared. Units squared, the calculated area. Area and coordinate geometry is units squared. Put that in the calculator. Anybody can work it out for me?
16 over 3.
Thank you very much. 16 and 3. And that is it. Nice and easy. All right. Don't get these questions wrong in the exam. They're too easy. Don't get them wrong. Next part. This comes on almost every exam paper. They give you a gradient function, they give you a point, and they ask for the equation. This point is for you to find the particular curve. In other words, you want to find the value of C. This is for you to find the value of C, constant of integration. When you integrate this initially, you're going to get the family of curves. That is one with the C. Simple. If dy by dx equals that, then y is equal to the integral of 3x squared minus 6x. Don't forget to put your with respect to x. Simple as that. When you integrate this, you're going to get the family of curves. In other words, you have to put in the plus c. Ready? Y equals, add on to this power, divided by the new power, I'm going to get x cubed. This one, add 1 to the power and divide by the 2, I'm going to get minus 3x squared. Then I'm adding my c, constant of integration. This represents the family of curves that I would differentiate to get this gradient function. I need to find a particular curve that corresponds to the curve that has that point on it. So I need to find the c. Find the c, I plug these values in the equation of the family of curves. So I say at the point 1, 2, the x is equal to 1, the y is equal to 2. I'm going to substitute them in there to find the c. So I'm going to get 2 equals 1 cubed is 1 minus 3 times 1 squared is negative 3 plus c. That implies that c equals what? This is a negative 2, comes over here, add to that 2, I get 4, c equals 4. Now that I have that, I write back my curve. This is now my curve, I'm writing back my answer. The curve, the particular curve is y equals x cubed minus 3x squared plus 4. This is the family of curves. All of those curves are sort of parallel to each other. They have the same gradient function. This is the particular curve that passes through this point. We call it the particular curve. Particular curve. The particular curve that passes through that point. This is a member of the family. But I got that.
Yes,
Yes,
sir.
sir.
Yes, sir.
And the answer integration question like this on almost every paper. Don't get it wrong. It's too easy. Don't get it wrong. All right, that finishes the 2016 question. Let's move up now to 2017. 2017 next. Working our way up. 2022. 2017 is right here. All right, so we're looking for the integration now. Bam. Like questions like this that tell me to prove something because I'm gonna get that answer when I'm done. I'm not gonna know that I'm right. All right, so they give you pi by 4. And this question we have to know that the sine of pi by 4 is equal to the cos of pi by 4 is equal to root over 2. So I give you those values enough, so you have to know it. So when you're doing the trigonometry question, they tell you this. But in this integration question, they don't tell you, you have to know it. But some calculators will give you this. Some calculators will give you this. So if you have that kind of calculator, then good. All right? So ready now. Ready now, ready now. We're going to integrate this and show it is equal to that, right? We're going to say the left-hand side, meaning here, is now equal to, I'm going to start the integration. When I integrate sine, I get minus cos. Because when I differentiate cos, I get minus sine. So this is minus cos x. When I integrate cos, I get sine. Because when I differentiate sine, I get cos. So this is plus 4 sine x. If you're not sure, differentiate this again, you're going to get that. And differentiate this again, you're going to get that. If you're not sure, you differentiate again. Put them back within the limits of pi by 4 and 0. Don't assume that 0 gives you 0. Remember, the cos of 0 is 1. Plenty people have the habit of thinking that 0 will always give you 0. The cos of 0 right here is 1. Right? So don't assume that 0 gives you 0. If you integrate that function, for example, that gives you like 2 to the x, remember that, for example, 2 to the 0 again is 1. So don't assume that 0 gives you 0. We're going to plug the values in here now. So left-hand side equals, plug in the pi by 4 first. In the first bracket, we're going to get minus the cos of pi by 4 plus 4 times the sine of pi by 4 minus the negative cos of 0 plus 4 times, let me shift this over, four times the sine of 0. I wrote them out. This one becomes minus root 2 over 2 plus 4 times root 2 over 2 in this first bracket, minus cos of 0 is 1, so this is negative 1, plus the sine of 0 is 0, so this is 0. And we're working towards this guy up here now, working towards that. So this becomes equal to, now this is 4 root 2 over 2 minus 1 root 2 over 2, so that's 3 root 2 over 2 right here. And you're adding 1. That 1 is the same as 2 over 2, because I want them to have the same denominator. Let's look at what we're getting again. See there? When you consolidate these, don't put the common denominator, you get the 3 root 2 plus 2 all over 2, which is the right-hand side. That was nice to show. Any questions there? But okay?
Yes, sir.
All right. So here we come now, our classic question. See? You have one of these on every paper. They give you a dy by dx, and they give you a point. This point is for you to find the c. Same thing again. It won't make no sense to get repeat questions wrong. So if dy by dx equals this, then y equals the integral of x plus 2. Don't forget the dx. Don't forget to put the dx. It's very important. You must integrate with respect to something. Don't forget to put the dx. I'm going to work this over here now. So the y is going to be, add 1 to this power and divide by the new power. It becomes x squared over 2 plus, integrate the 2, we're going to get 2x plus your c. plus the c. Let's use a different color here. We're going from here to here. All right. Then we're going to use this point to find the c. Find the c. So we're going to say at P23, the y is 3 and the x is 2. Plug them in the equation to find the c. So therefore, 3 becomes equal to 2 right here is 2 squared over 2, which is 2, plus 2 times 2 is 4, plus c. This is 6. 6 subtracted over there give me negative 3. So my c is negative 3. Then I can write back this equation now as my answer here. So y equals x squared over 2 plus 2x minus 3. And that is the answer. Nice and easy. I will stay. Are you good with that?
Yes, sir.
All right. Anything you don't understand, talk, let me know. All right. So give me this to integrate. I can integrate it as it is as a composite, you know. But I also can expand it out into separate term because it's just a square. All right. I can integrate it as a composite because when I differentiate what's inside, I'm going to get negative 1. So let's say I'm expanding it out into separate terms. When you can expand it into separate terms, you do it. It's easier sometimes. This will become the integral from 1 to 2 of first term squared is 16. Twice product of a 2 is negative 8x. And the second term squared is a positive x squared, not a negative x squared, a positive x squared. You're squaring negative x, remember? And then you integrate with respect to x. Then we'll just integrate term by term. This is equal to integral of 16x, 16 is 16x, minus, add 1 to this power and divide by the new power, I'm going to get 4x squared. 4x squared. Integrate this one, I'm going to get x cubed on 3. All of that between 2 and 1. Plug in the 2 and then plug in the 1. So this is equal to, I'm plugging in 2 first. 2 inside here is going to give me 32. 2 inside here is going to give me 16. 2 inside here is going to give me 8 on 3. Minus, plugging in the 1. 1 inside here is going to give me 16. 1 inside here is going to give me negative 4. 1 inside here is going to give me a third. Equals, write that out with the calculator and we're good. I'm going to do it that way and show you, you know. What's the answer?
19 over 3.
19 on 3. Let's work it out the other way. Let's work it out the other way. Let me put on the next side of the screen and work it out as a composite and show you. Just to show you if you decide to work it out as a composite, what would happen? Now let's do it that way. So if I decide to work it out as a composite, on here, this one again, if I decide to work it out as a composite, right? So I have the integral from 1 to 2 of 4 minus x squared with respect to x to be equal to, I'm going to integrate this as a composite. So I treat first as if it is x squared. So it will become 4 minus x cubed over 3, but I also have to divide by the differential of what's in the bracket. When I differentiate what's in the bracket, I'm going to get negative 1, and I can only divide by a constant. If, for example, this was an x squared, when I differentiate what's in the bracket, I would get negative 2x. I cannot divide by negative 2x. I can only divide by a constant when I'm integrating. Remember that. Whereas with differentiation, you can differentiate by whatever you differentiate in the bracket. With integration, you can only divide by a constant. Because the differential of what's inside here is a negative 1. I can divide by that negative 1. And then I'm putting back limits of 2 and 1. And then now this under here can be brought outside as a negative third into 4 minus x cubed between 2 and 1, just to simplify it. So I take this under here outside as a negative third. just to simplify. Then I'm gonna get minus a third into, I'm gonna plug the 2 inside there first. It's gonna be 4 minus 2 is 2, 2 cube is 8, minus, plug in the 1 there now. It's gonna be 4 minus 1 is 3, 3 cube is 27, 27. Now what is 8 minus 27? That's negative 19. So it's minus a third times negative 19. The minus makes us a positive, and so it becomes 19 over 3, just the same as we have right here. So you see, could have done it this way as well. All right? So your choice what you want to do. I think it's easier to just expand it out to the separate terms. Not really easy, that's different. That's different. All right, let's go. Next question. The next question says we are to calculate the volume of the solid form when the area enclosed by this curve, the x-axis, x equals 0 and x equals 6, are rotated 2 pi radians about x-axis. So that's volume of revolution. Now remember, volume of revolution is pi. Plenty of people forget the pi. Times the integral of y squared dx when you revolve around the x-axis. You're going between 0 and 6. Don't forget the pi. And remember, it's y squared. All right? Y squared. It's like you're finding the volume of a disk. And it is pi r squared h. And the h is actually your dx. That's what it is really, you know. Just like you're finding the volume of a disk. And this is pi r squared h. So the h is your dx. Similar thing, you know. That's the basic principle that it comes from. All right? All right. So don't forget the pi and it's y squared. So already know the y is actually x over 2. So this volume that we want becomes equal to the integral. Don't forget the pi. Y squared means that we're squaring that. So it becomes x squared over 4 dx between 0 and 6. So but I give it that. This over here is a constant. You can bring it under the pi. You can bring that constant under the pi and write it as pi by 4 times the integral of x squared dx between 0 and 6. Then it becomes equal to pi on 4 into x cubed over 3 between 6 and 0. This 0 is going to give you 0 this time. So it's going to become pi over 4 into, plug in the 6 first. I'm going to get 6 cubed over 3. Plug in the 0. I'm going to get 0. Write that out. We're going to leave the answer in terms of pi. What is 6 cubed over 3 equal to?
72 pi.
216. How much? 72?
Yes.
Everything work out to 72 pi? Everything work out to what? 72 pi?
Yes, sir.
Maybe I have to divide by the 4 too, you know. Maybe I have to divide by this 4 as well.
18 pi.
So it's really 18 pi. So it's 18 pi. And make sure you say units cube. That is it. All right, beautiful. Let's not get these questions wrong. They're too easy. Don't get easy questions wrong. All right. 2018 next. 2018. 2018 is right here. All right, let's see now. Let us see what they want. We didn't do this question yet? Nope. All right, look at this now. 2018. All right, this question says, show using integration that the finite region, that the finite area of the curve y equals sine x in the first quadrant, bounded by the line x equals 4 pi by 9 is smaller than the region y equals cos x in the same quadrant bounded by the same line. Aha, I like it. What does that mean? We have to know the curve y equals sin x and curve y equals cos x. So we can see what region they're talking about. We don't have to actually see it, you know, but it's good if we can visualize it, right? So comparing two areas, I want to see which one is smaller. And it's a show by integration. So I have to show all the working. So we're doing y equals sin x and y equals cos x. Let me sketch both of them for you. So the y equals sin x graph would basically be like this. Start at 0 and it goes up to 1, comes down to a low of -1. Right here is pi by 2. Right here is pi. Right here is 3 pi by 2. And right here is 2 pi. Now this is 4 pi by 9. 4 pi by 9, if you put it relative to this half, right, the pi by 2 would be the same as 4.5 pi by 9. Right? This and this will be the same, right? So this 4 pi by 9 actually comes before the pi by 2. So it means that my region is basically right up to here. The region that I want is just before here, just before pi by 2. It's right about here. So this is the region that I want on that curve. But I can appreciate that. That's 4 pi by 9. So if we were to move this, that's where 4 pi by 9 would be. 4 pi by 9. So I'm trying to find this purple area between 0 and 4 pi by 9 under the sine graph. All right? Just wanted to show you that. And if I'm going to show this cos graph, just first to have a visual of it, we're to show the cos graph. Let's do it half and half. Cut the page in half. We're to show the cos graph instead. Y equals cos x. And that graph would look like this. The cos graph starts up at 1, go like that, and finishes up at 1. That's a cos graph. And the values is right here is pi by 2. Right here is pi. No, so yeah, right here is 0. This right here is pi. Right here is 3 pi by 2. And right where it finishes is 2 pi. That is the cos graph. So this is cos x. Again, the 4 pi by 9 is before the pi by 2. So we're talking about maybe right here. So this now wants this area. And this is the y-axis. This is the x-axis. You're supposed to know the sine graph and the cos graph. You know? So let me erase this. Put in the purple mark. Right here will be the pi by 2. Right here will be pi by 2. So I can put it up here for you. But we're going up to 4 pi by 9, which is less than 4 pi by 9, which is less than pi by 2. 4 pi by 9. All right? That is it. So we're comparing those two purple areas. So to find out the area of each of them, is already down the middle or black down the middle here. To find the area of those two regions and compare the areas. That's what it is. All right? Let's do the sine graph first. It's the same thing. The area is the integral of sine, integral of y dx. Let's put up here. Area is the integral of y dx between 0 and 4 pi by 9. That is it now, whichever graph it is. So if we're doing over here, the area, let's call it area under the sine graph, because we're talking about the sine graph. It comes to the integral from 0 to 4 pi by 9 of sine x with respect to x. We integrate sine and get minus cos. We differentiate cos to get minus sine. So this area becomes minus cos x between 4 pi by 9 and 0. Don't assume that 0 gives a 0. Cos of 0 is 1. So the area under the sine graph becomes equal to. We're going to plug in the 4 pi by 9 first. So the first bracket is going to get minus the cos of 4 pi by 9 minus The second bracket, we're going to get minus the cos of 0. So somebody wrote this out for me, please, and just give me as a decimal. Just work out everything for me and give me as a decimal. That one. Just put it in the calculator as it.
0.826.
So we're going to get 0.826, and that is units squared. Let's do this one over here now. This one over here now, let's call it AC for the area under the cost graph. AC. So I'm going to get the area under the cost graph is the integral from 0 to 4 pi by 9 of cos x dx. That's that purple area there that we have shaded. And that area under the cost graph becomes equal to, now when you integrate cos x, they're going to get sin x. Because when you differentiate sin x, to get cos x. So this becomes sin x between 4 pi by 9, 4 pi by 9 and 0. So this area under the cost graph becomes sine of 4 pi by 9 minus, and I plug in the 0 now, to get the sine of 0. So write this out for me now. Again, here under the sine graph, and here under the cost graph is what? What again?
0.985.
What again?
0.985.
0.985 units squared. So you see, which one of them says less? You say the area under the sine graph is smaller than the area under the cost graph. And we have shown it, right? This is the area under the sine graph, which is that is smaller than the area under the cost graph. Therefore, shown. Area under the sine graph is less than the area under the cost graph. And that's it. That's the answer. We're showing it. But we get a lower value than this one. See, get less, smaller area. So it has been shown. The area under the sine graph is smaller than the area under the cost graph in the same region. So it has been shown. Just like that. Very good?
Yes,
Like
sir.
this question. 6 marks for that question. I love it. Love it. This one now. This one says, the finite region in the first quadrant bounded by this curve, the x-axis, the line x equals 4, are rotated about the x-axis. Determine the volume of revolution. Determine the volume of revolution. All right. So remember the volume of revolution, and it's in the first quadrant, you know, so we're basically saying it's between 0 and 4, because it's in the first quadrant. Between 0 and 4. So it's basically like you have this, like you have this curve. And you have a curve, maybe it's like this. So the curve is like this. Or maybe like this, because it's gonna be everything above the x-axis. So it's maybe like that. And the cross y-axis is at 3. I'm talking about where x equals 4, maybe right about here. Where x equals 4 is maybe around here. I'm talking about this area. Something like that. I don't know the actual sketch, but something like that. That's what they want, right? So go between 0 and 4. So in simple terms, the area that they want of revolution, not the area, this area is revolved. The volume that they want, the volume, remember, is pi times the integral of y squared dx. So this question is unreasonable. Remember this question now again. This question is unreasonable. It's 4 marks for it. The 6 you do this thing all the time. And to get the volume, we're going to have to square this and expand it out into separate terms. We have to square it, you know, because the integral of y squared. So I think CSEC actually made a mistake with this question. I don't think they intended to give that. Too much work for 4 marks. Right? That's another question where CSEC was unreasonable from 0 to 4. Right? Unreasonable, y squared dx. So we're going to have to square this and expand it out into separate terms. We're having a choice. Everybody get the same question to do. So the volume becomes pi times the integral of x squared plus x plus 3. X squared plus x plus 3 all squared dx is the volume I want to know, the volume. So I have to square the y. So how do we square this y? Multiply it by itself. You have to expand it out into separate terms. I cannot integrate this as a composite. When we differentiate inside here, getting 2x plus 1. You can't divide by anything with an x in it. So you have no choice but to expand this out into separate terms. All right, so let's go. V equals 5 times the integral. I'm going to multiply this by itself. So like you're taking the x squared and multiplying it by everything. So like it's like expanding this. X squared plus x plus 3 times the same thing. Times the same thing. X squared plus x plus 3. That's what they're doing really. This is another unreasonable question that takes CSEC. So we're gonna do this times each of these 3 things first. Right? We have to expand it out in the separate term if we're gonna finish the question. So it's x to the 4th power, and then plus x cubed, and then plus 3x squared. So I finish using that. Then we have to use this now and multiply each of these 3 things. I'm gonna put like terms under each other. So it's x times x squared first, it's gonna give me another x cubed here. It's a plus. And then this time is another x squared, so it's plus x squared here. And then this time this gives me 3x. I'm going to get a plus 3x. I have to use this 3 and multiply each of them. So I'm going to get 3x squared first. I'm going to put it right under the x squared term. I'm going to get plus 3x squared. Then 3 times that x is 3x, so I get plus 3x. And then 3 times that 3 is 9. I'm going to put everything dx. Consolidate the value. I have to work it down here, guys. I have to work it on here. This is an unreasonable question. This don't make no sense. Let me split this page and do it over this side. Right? I think it's another mistake question. They did not intend to set it like that. Maybe they intended to put a square on this. Or maybe leave off one of these, but I don't think they intended to do that. But that's what happens sometimes in CSEC. But it's about work what they get. Right? They make mistakes all the time. All right. So what does work out to? This work out to the volume being equal to pi times the integral. I'm going to consolidate the values now. Oh, we're going from 0 to 4, right? 0 to 4, 0 to 4, because we're in the first quadrant. So it's from 0 to 4. All right. So we're going to get x to the 4th power. Then the x cube is 2 of them. So we get 2x cubed. And then the squared term is 7 of them, 7x squared. The next term is 6 of them, 6x squared, plus 6x, I mean, plus 9. Let me shift this over. Because I don't want to forget to put the dx. That's what I get to do now, guys. So this becomes equal to pi into x to the 5th power over 5 plus this becomes 2x to the 4th power over 4 plus 7x cubed over 3 plus 6x squared over 2 plus 9x between 4 and 0. 4 and 0. The 0 is going to give you a 0 everywhere, right? The 0 is going to give you a 0 everywhere. So we don't need to work out the value with the 4. So the pi is going to be equal to pi into 4 to the 5th power over 5 plus 2 times 4 to the 4th power over 4 plus 7 times 4 cubed over 3 plus 6 times 4 squared over 2 plus 9 times 4. And for you can put minus 0 for this. And then whatever this works out to, you're going to put something pi units cubed. I won't even bother ask you to work it out. Whatever this works out to goes there. All right? I won't bother ask you to work it out. I don't think they intended it to be that way. Because it was unreasonable for 4 marks. Unreasonable for 4 marks. They made a mistake with this function that I put there. All right? Or maybe they intended to ask area, but they're going to ask volume. But it happens from time to time. It's unreasonable, but it happens. Human beings make it right in the questions. And, sometimes CSEC is not so thorough. Let's put it that way. Another classic question, I'm going to give a dy by dx and give you a point. This point is for you to find the c. All right? So the same thing again. The y is going to be equal to the integral of 3x minus 1 dx. So y is going to be 3x squared over 2 minus x plus c. Then using this point, I'm going to put at a 4, 1, the x is 4 and the y is 1. I'm going to drop them in the equation. So that will become 1 equals, put the 4 right here. I get 3 times 4 squared over 2 minus 4 plus c. It means that the c equals what? Can somebody write that out for me? This becomes 16 over 2 is 8. 8 is 24. 24 minus 4 is 20. Going to go over there and subtract them 90. Just c equals negative 90. All right. And then this therefore is y equals 3x squared over 2 minus x minus 90. And that is it. Easy. See, 4 marks for this now, and 4 marks for this. See, that makes sense. There's no way this could be 4 marks. No way. So I don't think they really intended to give this. We have to square it into all these terms. Right? We have over here. This don't make any sense. It's too much. All right? But that's happened sometimes. 2019 next, guys. 2019. 2019 next. Looks like we're going to be able to do some probability today. We're going to do either probability or statistics. Another two. All right, 2019. 2019. All right, down here. Ready again. Simple stuff. It gets easier. It gets easier. I want us to integrate this. Let's just write equal. Don't forget to put the C. By the way, did I forget to put the C on a previous question? Don't forget to put the C when you integrate without limits, right? Don't forget to put the C. When you integrate cos, you're going to get sine, because when you differentiate sine, you get cos. So it's going to become 3 sine x. When you integrate sine, you're going to get minus cos, because when you differentiate cos, you get minus sine. So it's going to become minus 2 cos x plus c. If you're not sure, you differentiate it again. If I differentiate this, I'm going to get that. Good. If I differentiate this, I'm going to get that. This is good. Because when I differentiate cos, I get minus sine. Minus minus give me a plus right there. All right? So that is it. Done. This one now. To get this to integrate. See, it look complicated. Simplify these and bring it to some power of x. Some power of x. All right? That's all you have to do. This is x to the half, So this is the integral of 1 to the 4, 2 times. And in fact, these 2 are multiplying constant. It can come outside here. It's a constant. I can bring it out here. 2. And so I'm focusing on this now. This is x to the half over x. This is x to the 1, What laws of indices say? You subtract the powers. So it becomes x to the half minus 1, which is minus half. So it becomes 2 times the integral from 1 to 4 of x to the minus half. See? Bring it to 1 power of x. Easy now. Add 1 to the power, divide by the new power. It becomes 2 times inside here. Add 1 to this power, it becomes half. So it becomes x to the half divided by the half between 4 and 1. To divide by this half up here is the same as to multiply by 2. So out here is just going to become 4. And inside there becomes the square root of x between 4 and 1. That's what it boils down to. X to the half is the square root of x. And so I can plug in the 4 and plug in the 2. So I get 4 into the square root of 4 minus the square root of 1. That becomes, this is 2, this is 1. 2 minus 1 is 1. So the answer is 4. That's the answer. 4 times 1 is 4. That's the answer. But I go to that. So pay attention to what I did here, guys. I brought it down and simplified it down to 1 simple power of x. All of this right here. So simplify it down to 1 power of x. This became this. All right? Bring it down to something simple. You always want to bring your thing x to some power when they give you those expressions. All right? Remember that one. That was a challenge for this discussion with some person. They realize that's all they needed to do. But okay with that?
Yes, sir.
Yes, sir.
All right. Very easy. Just remember, the question is easy, you know. So if they look hard, they look at them easy. But they are easy. All right? Just mean that there's something that you're not seeing. All right. The teacher again, same thing. I give you a dy by dx and a point to find the curve. All right. So we're going to integrate. So y equals the integral of minus 2x. It's minus 2x plus 1. Can be written as 1 minus 2x, you know, same thing. So I'm going to put 1 minus 2x. 1 minus 2x dx. Same thing. Then I'm going to integrate. It becomes x. When I integrate 1, I get x. When I integrate 2x, I get x squared. Minus x squared plus c. So y is equal to that. Plug this point into there now. Right? This point into there. 2, 4. X equals 2, y equals 4. Plug them in there. Therefore, 4 equals, y is 4. The x is 2 right here. Minus 2 squared plus c. This is 2 minus 4 is negative 2. Negative 2 carries over there, add to the 4, give me 6. So this tells me that the c equals 6. And then I can write back the equation. Where's mom? Mom upstairs? So y equals x minus x squared plus 6. That is it. Very good at that?
Yes, sir.
All right. Continue right here. You must find the area under the same curve, finite region. Or let's see. It says the area under the curve, you must find the area under the curve, the finite region, the first quadrant between 0 and 3 on the x-axis. Okay. So I want the area under this curve now. See? That is the curve now, you know. I want the area under it. So that area that I want is the integral from 0 to 3. This is the y now. Which is x minus x squared plus 6. Don't forget to put the dx. That's what you're working on now. Integrating again. So that area equals x squared over 2. Integrate this, you get x squared over 2. Integrate this, you get x cubed over 3. Integrate this, you get 6x. And you go in between 3 and 0. The 0 is going to give you a 0 everywhere this time. Just need to work out what we're going to put the 3. So that area comes equal to, plug in the 3 first. We get 3 squared over 2 minus 3 cubed over 3 plus 6 times 3. In the first bracket minus this 0, as I said, is going to give you 0. I need to show it. And I can shift this over and put an equal right here and put the answer and write units squared. unit square. Somebody wrote this out for me?
13.5.
13.5 unit square. Alrighty. That looks like 26 over 2. 13.5. All right, that is that. Question done and question done. That's 2019. Going up to 2021. 2021, finishing fast and furious. 2021 is right here. 2021. Integrate this thing. Let's see. I think now we're gonna see some motion and straight line coming in these questions again. 2021 wants us to integrate this. Easy stuff. Add 1 to the power divided by the new power. Don't forget the constant of integration. So this is equal to 2x cubed over 3. We integrate this one. Plus, add 1 to this power divided by the new power. 3x squared over 2 plus c. Don't forget the plus c, because there are no limits on it. That is it. All right? 3 marks. That's like 3 marks. This one, to integrate this one now. Remember, we integrate this now for divide by the difference of the 3x now. We integrate sine, you're gonna get minus cos. When we differentiate cos, you get minus sine. So it's gonna become 2, well, actually minus 2 cos 3x. We divide by differential of this 3x, which is 3 plus c. If you're not sure, differentiate this again. If you differentiate this again, that's what you're gonna get. If you differentiate this right now, treat this as a constant. Minus 2 and 3. Differentiate this now. What would you get? You will get minus 3 sine 3x. So this would cancel this, and the negative gone as well. Look at it now. The minus will be a plus, and this 3 cancels this 3. You will get 2 sine 3x, which is what we just integrated. So if you're not sure, differentiate it again and see if it works. We differentiate the constant to get 0. So this is correct. What I did, I divided by the differential of the 3x. I divided it because you're doing the reverse process of the differentiation. If you're differentiating, you have to multiply by the differential of the 3x, which is 3. When you're integrating, you have to divide by the differential of the 3x, which is 3. Plenty of persons will leave that out. Don't leave it out. As I said, if you're not sure, differentiate what you got and see if you get that back. Just differentiate it again. All right, that is that. 3 marks for that, 3 marks for that. 3 marks for doing that. And this part of it was keep divided by the 3. All right, let's go. This question says, using an integration method, calculate the area of the final region, first quadrant under the square, y equals 2x. The first quadrant. This graph would look like this. This graph would look like this. It would go like so. Since this is 3, this one is going to go up to 3 and go down to negative 3 because it is y equals 3 sine x. Y equals 3 sine x. Sine x itself can only go up to 1 and go down to negative 1. Right? This is negative 3. And so multiplying those values by 3. Right? Multiplying those values by 3. So that is it. And so they want us to find here in the first quadrant, meaning they want us to go up to pi. So between 0 and pi, right? Here's pi by 2, you know. So they want us to go up to pi. All right, so it's the area of the pi, up to pi. So they're asking us for this area in the first quadrant. Right? That's the first quadrant. In the first quadrant, let's see, calculate the area of the region in the first quadrant under the curve. Yeah, this is the first quadrant. All right, area in the first quadrant under the curve. It's here. All right, in the first quadrant under the curve. So that area is that. So they want the integral of between 0 and pi of 3 sine x dx. That is the area. That's the integral of y dx. All right. This 3 can come out here as a multiplying constant. So it can be a equals 3 times the integral between 0 and pi of sine x dx. We integrate sine, you get minus cos. And we differentiate cos, you get minus sine. So it becomes 3 times minus cos x between 0 and pi. This minus can come out here as well, you know. So we can go ahead and write that as minus 3 cos x between pi and 0. Now remember, none of this is giving us 0 now, because the cos of 0 is 1. It's going to give you 1, it's going to give you a minus 1. So that's what's gonna, it's minus 3 into cos of pi minus the cos of 0. And you can put that in the calculator. This is going to be negative 1 minus 1. That's what it's going to be. You know? So the answer is going to be positive 6 when you're done. It's going to be minus 3 into, this is minus 1, minus, this is minus 1, this is minus 1, minus, this is a minus, and the cos of 0 is 1. So this is a negative 2 times a negative 3, that's a positive 6, as equals 6 units squared. That is the answer, 6 units squared. That is it. What do you go to that?
Yes, sir.
Okay. All right. All right. That is that. Just you have to know the sketch of the graph, guys. Right? It was a cost graph. It was a cost graph. Let's say it was a cost graph instead. Let's just say it was a cost graph instead. Because I could repeat the question in but give it a cost graph next time. All right. Let me show you what we'll have to do. It was a cost graph instead. So they have to anticipate what CSEC will do. So I might give back the same question and change the cost. So let's say it was, let's say instead it was y equals 3 cos x. The one in the first quadrant again. Cost graph is like this. The first quadrant, the cost graph is like this now. So look at the values. The values will go like this. So the cost graph is in, that is a cost graph. You draw it in blue. The cost graph starts up at 1 and goes down and go like that. All right. This is the y-axis. Now it's 3 cost graph. Remember the cost itself going between 0 and 1. So you multiply that by 3 again. It goes up to 3 right here and goes down to negative 3 right here. But the first quadrant is between the x and the y-axis here. So we're talking about this area. But what happens here now is that right here is pi by 2. So in this case, it will be between 0 and pi by 2. But that's in the first quadrant. But that is pi by 2. Right here says pi. Right here says 3 pi by 2. And out here is 2 pi. Right? So the difference in this graph, the sine graph, right here so is pi by 2. Right here says pi by 2, where it turns first. When it comes on the axis at pi, and right here is 3 pi by 2. Then right here is 2 pi. Put them below. So right here is 3 pi by 2. Right here is 3 pi by 2. It's 3 times 90. Like going up by 90, intervals of 90 degrees. And right here is 2 pi. It's broken down into 4 integrals of 90. So that go after something significant every 90 degrees. So 90 degrees when it reach maximum first. 90 degrees more is when you reach by the x-axis. 90 degrees more is when it turn again. And 90 degrees when it reach by the x-axis. Same thing, this one broken down into 90 degree segments. So in the first quadrant for this one, the area would have been now. Area would have been in the first quadrant would have been right here. So the area would have been the integral of 3 cos x between 0 and pi by 2 instead. So whereas the sine graph in the first quadrant is from 0 to pi, so we integrate between 0 and pi. For the cost graph, the first quadrant is between 0 and pi by 2, right here in the first quadrant, 0 and pi by 2. That's what they were talking about, dx. And so if we're to complete this, integral of cos is sine, so that area will be equal to, we can move out the 3 again, same way, this 3 can come outside here. So we can put 3 into, then the integral of cos is sine x, so we'll have sine x between pi by 2 and 0. And so that area will be 3 into sine of pi by 2, which is 1 minus the sine of 0. And this is sine of pi by 2 is 1. So this will be equal to 3 into 1 minus 0. But the sine of 0 is 0. So this answer will be 3 units squared if it was a cos instead. So note, this is how the cos graph goes. Look at it, know these things. That's how the cos graph goes. And this is a sine graph. Sine graph starts at 0, guys. But the sine of 0 is 0. The cos graph starts up at the value up here. Cos graph starts up at 1. The cos graph starts at 1 itself because I'm multiplying by 3. That's why this is amplified by 3. All right. Anyway, let's continue. What else is there to do in this paper? Over here. All right. See here now. This is our kinematics. We're going to see the kinematics coming up in these questions now on the recent paper since 2021 when the syllabus changed. It says a particle starting from rest, travels in a straight line with an acceleration a given as this. So this is acceleration. Now how it is, remember, to go from displacement, S is for displacement. You differentiate displacement to get velocity. You differentiate velocity to get acceleration. This is differentiate. Then to go the other way, to go from acceleration back to velocity, and from velocity back to displacement, you integrate. All right? You integrate. All right? So since we started at acceleration, to go to velocity, we have to integrate. And to go from velocity to displacement, we have to integrate again. All right. Question says, determine the velocity of the particle in terms of t. All right? Now, this thing is very important in this. When I'm saying starts from rest means, that statement means that when t equals 0, when it starts, the velocity is 0. That's what it means, you know. It starts from rest. A particle starting from rest. Starting means t equals 0. The velocity is 0 because it starts from rest. So we have the acceleration here. It is equal to t squared. The velocity is the integral of the acceleration with respect to time. So to integrate this to get the velocity, so it becomes the integral of t squared dt. And so the velocity becomes t cubed over 3 plus c. But the c is 0 this time. Why is the c 0? Because they said when t equals 0, v equals 0. So if this is 0 and this is 0, then it means that the c is also 0. So c is 0 this time. So we can say therefore c is also 0. And so our velocity formula is just that. We can write the answer and say therefore the velocity is just t cubed on 3. Let me make this a little smaller. Let me make some of this a little smaller right here. Let's make that a little smaller. Right? So this is the velocity formula right here. So you cannot ignore that sentence, guys. That starting from rest. It means that when t equals 0, starting is when t equals 0, the velocity is 0 because it started at rest. It says now calculate displacement s of the particle in the interval between 0 and 2. So let me explain what is happening here now. What is happening here is like almost like we can draw that velocity graph. You know? So we can put this into perspective. Like we can draw this velocity graph, and it's a t cubed graph. So if we were to draw a velocity time graph, this is the same as 1/3 t cube, right? So if we draw a velocity graph, v against 1/3 t cube, it will basically look like this. The cubic graph go like so, you know. Cubic graph generally go like so, you know, go like so. If it was y equals x cubed, that's how it would look. Y equals x cubed. If we draw it fully on a graph, like so. That's how it would look. Y equals x cubed. But is a 1/3 t cubed. The third is just a multiplying constant, so it's gonna still shape like this. So if we're drawing that velocity graph based on that, and put a velocity time graph instead of x and y graph, right? Then the graph, let's draw it in a different color. We basically go like this and go like that, just the same. But we really only want this part of it up here, because it starts from rest when t equals 0, the velocity is 0. So we really only want this part of it. So I'm going to take out the black part. So that would represent my velocity time graph. I'm just trying to let you understand what does that mean. That's a velocity time graph. So that is my velocity time graph, right? And I want the distance traveled, the displacement. Now remember, displacement is distance, right? And it's going in one direction, because you see, if you notice, it's above the x-axis all the time. And it's from t equals 0 to t equals 1. So from not t equals 0 to t equals 2. So it's from t equals 0 to t equals 2. Let's say 2 is right here. So basically, they want the area under the graph right here. That's the distance traveled. Remember, distance traveled is area under the velocity time graph. So if you treat this as a velocity time graph, then the distance traveled is the area under the graph. And the area under the graph is the integral of the velocity time graph, because this is not a smooth curve. This is not a straight line or anything like that. On the area under the graph, you have to integrate. So if you bring it back to integration, then the area under the graph is the displacement, which is the distance same way. So the displacement S will be the integral of the velocity graph with respect to time between 0 and 2. Comes back to that, you know, and the velocity happens to be this. So we're actually working on the integral of a 1/3 t cubed between 0 and 2 to get that displacement corresponding to this area under the graph right here. But this will be the area of this graph. This will be the graph, that graph here. This red graph will be for this function. We'll just sketch it. And so that's what we're working on, guys. Simple as that. Just wanted to put it into perspective for you. So S will be equal to, this is a multiplying constant at third. So we're going to put the third outside. We're going to integrate the t cube. Let's put dt. Let's not forget the dt. So that's going to go t to the 4th power over 4. If I integrate the t cube, we get t to the 4th power over 4 between 2 and 0. Right? This 4 can come under here with this and give me 1 over 12. So I'm going to get S equals 1 over 12 into, and plug the 2 inside here, I get 2 to the 4th power. And then plug the 0 there, I get minus 0. And get my final answer there. So 2 to the 4th power is what? 16? 16 over 12, right? 16 over 12 is 4 over 3, don't? So I get 4 over 3 meters is the distance traveled. Hope you understand, guys. I'm just trying to relate it back to what we know about a velocity time graph. That distance from a velocity time graph is area under the graph. I get area under a graph by integrating the graph function. And the graph function is a v function. So integrating the v function between the limits of 0 and 2. Because this area is what they would want if we use a graph, if we represented it graphically. All right, that is it. Okay, but if you never know that, you could just know that to get displacement by integrating velocity, as we did here, and you go in between 0 and 2 just the same, and you put those as your limits and get the answer just the same. Even if you didn't know that, but I'm just trying to connect it for you. All right, but that is it. 2022 next. 2022. 2022. What time is it now? What time is the word finish? 4? Finishing 5 over here. So another hour then. So we can do some probability after this. All right. We can take a 10 minutes break after these last 2 questions, and then we're going to come back on the probability. So we're leaving statistics for tomorrow. So we're not going to bother to have any session tonight. Our process of biology to study for tomorrow. So we're just going to finish off with these. We're going to finish off the next hour by doing some of the probability questions. Persons prefer to do the probability. Probability is different from statistics. So we're going to do the probability and save the statistics for tomorrow. All right? So let's go. So this now I want to integrate this same thing again. When you integrate cos, you're going to get sine, because when you differentiate sine, you get cos. That's just 4 sine theta. When you integrate sine, you get minus cos, because you differentiate cos, you get minus. When you differentiate cos, you get minus sine. So when you integrate this, you're going to get back a positive 6 cos theta. And don't forget your c. If you're not sure, you just differentiate that again. When we differentiate this, we get that, which is good. When we differentiate this, we get that, which is good. Differentiate the constant, we get 0. So that is correct. Now I'm going to integrate this now. I can integrate as a composite as I did before, but I can also expand it out into separate terms. We did one like this earlier. So I can choose to expand it out into separate terms and put 1 to 2 and expand this out. We did one earlier. All right? We did one earlier. The same sort of stuff. Like expand it out in separate term because it is just a square. What's happening here? It's gone, we're gone. It's just gone. It's doing its own thing. What's happening? What's happening to Reese? All right. So between 0 and 2, expand this out into separate terms. First term squared is 9. Twice the product of 2 give me negative 6x. Second term squared, remember, is a positive x squared. So this is almost a repeat question. We did one like this earlier. This becomes equal to integral of 9 is 9x. Integral of this becomes 6x squared over 2, so it becomes minus 3x squared. We gotta cancel that. Integrate this, we get x cubed over 3, and we're going between 2 and 1. Mom is up there? Huh? You should not come and get him. All right, plug in the 2 and then plug in the 1. So we get 9 times 2. We cannot write the values now. Those are small values. 9 2 is 18. Plug in the 2 first. 9 2 is 18. Minus 2 squared is 4 times 3 is 12. Plus 2 cubed is 8. That's 8 and 3. Minus, plug in the 1 now. 9 times 1 is 9. We plug the 1 there, we're going to get minus 3. Plug the 1 here, we're going to get plus a third. Put everything in calculator for me, please. Tell me what you get.
Minus 11 over 3.
Minus 11 and 3. That's it. All right. Then we come to this question. Let me go and see about the dog a little bit. Hold on 1 second, please. Let me go and see about the dog and see what's up with it. Give me a second, please. Just give me a second, please. 1 All right, guys, sorry about that. All right, so let's go. All right, so we now want to determine the area of the region bounded by this curve, the x-axis, the y-axis, and the line x equals 2. Now the y-axis is the line x equals 0 now. So it means that we integrate between 0 and 2, this curve. All right, simple stuff. That's the area. So the area that we want, we're going to integral between 0 and 2 of y dx, and y is 5 plus 5x minus x squared. Don't forget to put on the dx, please. So the area equals 5x. When you integrate this one, we're gonna get 5x squared over 2 minus, integrate this one, we're gonna get x cubed over 3 between 2 and 0. The 0 is gonna give you a 0 everywhere. So just the 2 that's gonna have a value, that's gonna produce a value. All right, so it's gonna be a equals, plug in the 2 now. Plug in the 2 here, we're gonna get 10. Plug in the 2 here, we're gonna get 20 and 2, we're gonna get 10 again. Right? We're gonna get 10 again. Plug in the 2 here, we're gonna get 8 over 3 minus, plug in the 0, we're gonna get 0 everywhere. And so work out that for me, and then all right, units squared as the answer. Units squared. What is work out to? That's 20 minus 8 over 3. What is it? Anybody?
52 over 3.
How much?
52 over 3.
52 over 3 units squared. Done. Then we'll come to another motion, a straight line question. A particle moves in a straight line so that t seconds after passing through a fixed point O, its acceleration A is given by this. It says when t equals 2, the particle has a velocity of 4 and its displacement is 6. So these are some times and conditions for you to find a constant. Let's write them down. When t equals 2, the velocity is 4 and the displacement is 6. So these are for you to find constants. Because when you integrate this to get the velocity, you're going to get a constant. So it's just to find the velocity when t equals 4 first. The velocity is the integral of the acceleration, which is 3t minus 1 with respect to t. When you integrate it first, we're going to get a constant. They're going to use these values to find a constant. So this is going to become, let me put these values in red. These are your conditions to find the constants. All right, let's change them to red. All right, so let's integrate this right here now. Don't have a lot of space. All right, we want the velocity when t equals 2. You can work it on yourself. Velocity equals, this becomes 3t squared over 2 minus, this becomes t when you integrate it, plus c. You have to plug these two values inside here and to find plus c. What did I write up? Write 1 plus c. Plug these two values in there to find the c. All right? So we're going to plug them in there. T equals 2, v equals 4. Plug them in there. 4 equals 3 times 2 squared over 2 minus 2 plus c. That implies that the c equals what? Let's work it out. C equals what? So we can know the formula. Now, this right here is a 6. 6 minus 2 is 4. So the c equals 0. Don't it? That's all?
Yes, sir.
C equals 0. So since the c equals 0, this velocity formula simply becomes, let me use a different color now. The velocity formula simply becomes v equals 3t squared over 2 minus t. That's what it becomes. And I want this, when the t is 4, that's what I want. What the velocity when t equals 4. So when t equals 4, the velocity becomes 3 times 4 squared over 2 minus 4. What is that? That's 16 over 2 is 8. That's 20, right? That's 20 meters per second. That's correct? I'm getting 20. That's correct?
Yes, sir.
20 meters per second. Done. So see if this information was irrelevant, the displacement part of it. Never need it at all. Question done. Right? Never need it at all. Did not need it. So sometimes I give information that they don't need, right? So don't get thrown off by that. All right. That is that. They wanted the velocity when t equals 4. That's it. Done. Next question. We're going to look at now 20. No, we're going to look at the specimen paper. That's what I put on the specimen paper, because I've seen where the specimen questions on the actual paper are very, very almost carbon copy of questions on the specimen paper. So it makes sense to do the specimen paper. All right, this is a specimen paper. All right, here now they just want us to integrate this. Now that's a cube. So I'm not going to expand it out. You have to just remember that when we integrate, we have to divide by the differential of what's inside the bracket once it's a constant. So first integrate it as if it is x cubed. So this is equal to, I'm just going to write what it is equal to. And don't forget your c. This becomes equal to 2x plus 1 to the power of 4 divided by the new power of 4. And also divide by the differential of what's inside here, which is at 2 plus c. So it actually becomes 1 over 8, 2x plus 1 to the power of 4 plus c. That's what it becomes. But go to that. But okay with that?
Yes, sir. Yes, sir.
This one now, so this one now, don't get tricked by this. Just divide it out into separate terms. This simply means this divided by that and this divided by that. Separate it out into separate terms. This x under here is x to the half. All right? So remember, when you divide this by this, you subtract the powers. So look what I'm going to get now. I'm going to get the integral of 7x. 3 minus half is 2.5, which is 5 over 2. 5 over 2 minus 1 over this x to the half becomes x to the minus half. X to the minus half with respect to x. But understand that. Gotta go to that. So separate it out into separate terms. But I go to this before I move on. That's why I make sure.
Yes, sir.
All right. And then once you have that, everything get nice and easy. Integrate term by term. Add 1 to this power. For 5 over 2, and I add 2 over 2, it becomes 7 over 2. So my new power is 7 over 2. So I'm going to write 7x to the 7 over 2 divided by the new power of 7 over 2. That's what this becomes. Minus, add 1 to this power becomes a half. So I get x to the half divided by the new power of a half. Don't forget to put your plus c because there are no limits. So divide by 7 over 2 is to multiply by 2 over 7. So this whole thing becomes a 2. I'm going to give them back with some root symbols, right? So since they gave us a question with some root symbols, give them back with some root symbols. So this 7 will cancel that 7. And I'm multiplying up that 2. So I'm going to get 2. This book means root of 2, root of the x, so it's root of the x, and I'm raising it to the power of 5. So it's x to the 5th power, like that. Minus, to divide by this half is to multiply by 2. This is root x again, root x plus c. That's it. I'll go to that. If you leave this now, CSEC will give you a marks, I think, if you leave that. I think they'll give you a marks if you leave that, right? So that is it. Tend to simplify expressions down. May doing them. But go to that.
So wouldn't it
All
be
right.
x to the power of 7?
Oh, thank you very much. X to the power 7. Thank you very much. It's not 5. It's x to the power 7. Yeah, that's true. 7. Good. So you see why I asked if everybody go to that. Thanks for that. X to the power 7. Beautiful. That's it. My mistake. All right, beautiful. Somebody's paying attention. At least one person is paying attention. This one, no. This one says, let's see the one, we draw the sign graph first this time, guys. The same question we did a while ago, you know. We just start instead of a 2, we're at 3. We just did y equals 3 sin x a while ago, you know. Just did y equals 3 sin x. See? Same graph I drew for you. So I drew the complete thing. And I told that I wanted this area between 0 and pi. See? Same thing. And see this one now. When we did the 3, it went up to 3. This one, 2, goes up to 2. See that? So we just did one a while ago with the 3x. So you see, questions are almost the same. This time is 2x. Same concept as one with 3x. All right? Let's see what they want us to do. And see, it's in the first quadrant again. So you see the first quadrant is what's inside between, and the positive side. The positive quadrant between the y and the x-axis. That's the first quadrant they're talking about. All right. So the question says, using an integration method, determine the area under the graph in the first quadrant. So it's the same thing again, right? We're finding this area, right? But this time they give it to you. The question we did a while ago, they did not help us, they did not show us in the graph. You had to know, and that's why I sketched it for you. All right. So the area that they want here now is the integral between 0 and pi of 2 sin x. I'm going to put the 2 out here because I constant. I put the sin x here, dx. All right, I just put the 2 on the outside because it is a constant, a multiplying constant. A multiplying constant can go there. A multiplying constant, not an addition constant. We're subtracting a multiplying constant. Then this is going to become 2 times. When you integrate sine, you're going to get minus cos x between pi and 0. Right? When you integrate sine, you're going to get minus cos, because when you differentiate cos, you get minus sine. This minus can come outside here again. You know? So I can put equal minus 2 cos x between pi and 0. Don't assume that 0 gives you 0. The cos of 0 is actually 1. This becomes minus 2 into the cos of pi minus the cos of 0. That's what they get. So I get minus 2. The cos of pi is negative 1 minus the cos of 0 is 1. That's minus 2 times minus 2 is the same 4. This is 4. I think we had gotten 6 the time before. 3 times 2 is 6. Units squared. That is it. All right. So it's a 6. You like to repeat questions. So they put it on the specimen paper with 2. They put it on the actual paper with 3. All right. That is that. Next question. It says, a particle moves a straight line so that its velocity k, so they are putting k as velocity, and I work with it in a k, and I'm going to change it and put v. I'm in the exam, I'm going to change it myself and put v. I'm going to say, put k equals v. I want to be the same as our number. Put k equals v. That's what I'm going to put. K equals v. Right? So I'm going to work with my v. K equals, I'm going to put k equals v. I don't know why they're changing. And I put in expression for the displacement W. I'm going to put W equals S. I'm going to put S right here as well. S. Put W equals S. Question says, a particle moves a straight line. So its velocity v in meters per second from a fixed point O is given as that equation there. It says where t represents time in seconds. It says now when t equals 3, the particle has a displacement S. Changes my W to S of 25. What that means? That's a condition. When t equals 3, S equals 25. This is for you to find a constant. It said determine an expression for the displacement of the particle. So to go from velocity to displacement, we have to integrate. To go from velocity to displacement, we have to integrate. The displacement is equal to the integral of the velocity with respect to time. Means that we're integrating this velocity which is 2t squared minus t with respect to time. We're going to get a constant. I'm going to use this to find a constant. So the displacement formula becomes, integrating this now, 2t cubed over 3 minus t squared over 2 plus a constant of integration. It says when t equals 2, we're going to use them.
Excuse me, sir.
Yes?
Shouldn't it be 2t cubed where you have integrate in the bracket, sir?
Oh, it's cube.
Yes, sir.
Oh, it's a cube. All right. Thanks. It's a cube. All right. Cube. Thanks for that. So it's cubed. So I misread. So it's cubed. All right. So this becomes to the 4th power over 4. All right. Thanks for that. All right. So this simplifies down into t to the 4th power over 2 minus t squared over 2 plus c. We're going to use the conditions that they gave us to find the c now. When t equals 3, the s is 25. That's what they said. When t equals 3, the s is 25. I'm going to plug them in there. So we're going to get 25 equals 3 to the 4th power over 2 minus 3 squared over 2 plus c. We have to find the c from this, guys. So I want to work out this for me and subtract it from 25. Work it out for me, please. Put this together and then subtract it from 25 and tell me what the c is. Therefore, c equals, remember I thought, c equals 25 minus the sum of these two. 3 to the 4th power over 2 minus 3 squared over 2. Work out that for me. Tell me what the c is.
Negative 11.
Negative 11 flat?
Yes,
Negative
sir.
11. So since that is negative 11, I'm going to take this now. This is a different color. This becomes the equation for s. S equals t to the 4th power over 2 minus t squared over 2 minus 11. The plus c is minus 11. That's it. Done. And that is that for question 6. How much time we have now? We have 45 minutes, guys. We're going to take a 5 minutes break. And we're going to come back and we're going to run some probability. Okay? Let's run through the probability of the question 7. The last question, we're going on to 2015. Remember, in the past, probability used to be a question by itself. That always comes statistics. Probability and statistics always come together. We're going to do the probability part of the questions. And then tomorrow, we'll do the statistics part of the question. Are you going to do that?
Yes, sir.
Yes, sir.
I want to do the other way around. I want to do the statistics part of the question today and the probability part tomorrow. Which one you prefer? Which one you prefer, guys? I don't matter to you.
It doesn't matter.
Don't matter. All right. All right. Let me put on the timer, and so we can think. I think I prefer to do the probability part in the body fresh. I think I'm going to do the statistics part. I think tomorrow when everybody is fresh, you know, at the beginning, right at the beginning with the probability, I think most persons understand the statistics a little bit more cleaner than they do the probability. So I'm going to put on a 5 minutes on this. I'm going to take a quick 5 minutes break. All right, guys, we're taking a 5 minutes break, and then we're going to jump. Let's just do the statistics part. We'll do the probability part tomorrow. So I think I want to do the probability part at the beginning when everybody's fresh. All right? So I'm going to do the statistics part of the questions. Like, for example, right here's probability. We're going to do the statistics part. This is probability. This is statistics. All right. All right, guys, let's go. Let's finish strong today. So we're gonna do the statistics, all right? We're gonna do statistics. So let's go. Remember, we're working all the way down to 2016. 2016. All right, so let's go. So again, we assume that you already know the topic and we're really just revising. All right, so this first question says, this is a stem and leaf diagram. All right, the number of cars parked on a local beachfront on each night in August last year is summarized in the following stem and leaf diagram. And they give us a key right here, right? What it means that, for example, this is 10 and this 5 is actually 15. And for example, this 8 is actually 48, and so on, right? Everybody understands that. All right? He said, determine the median and the quartiles. Determine the median and the quartile. Well, the median is actually one of the quartiles. And it just said the quartiles are talking about Q1 and Q3. So we need to break down the data. We need to break down the data. So the first thing we need to know is how many values are there. So you can just count them straight and add them up. I'm counting them straight. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31. There are 31 values there, so it's friendly. 31 values can be broken down into 15 and 15 and 1 in the middle. All right, and the 1 in the middle is going to be our median. Right? 15 and 15 and 1. So we need to divide the data into a bottom half of 15 and a top half of 15. And then we're going to have 1 in the middle. The 1 in the middle is going to be the median. So we just need to count the first 15 values. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. That's my 15th value. And so my first half, to show it like this, would be right here. Right here is my first half. These values. My first 15 values. Let's draw it like this again. That's the bottom half of the data. And the top half of the data means a different color. It's the same color, no problem. Would be these 15 up here. The one that I'm leaving out in the middle there is my median. So my median is this one right here. This is my median value. That's my median. Let's double check that. Must have 15 values down here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Good. So that value there is my median value. I'm using the construction method. There's also a formula method that can be used. When the values are in front of me, I can just construct it. That is Q. That value is Q2, the median. So Q2 is 41. Q2 is 41. Then now, the middle of this 15 values is Q1. There are 15 values there. So again, it's a friendly value because it's odd. So I'm going to have 7 values below Q1 and 7 values above Q1. So I just need to count 7 values. The 8th value is Q1. So it's 1, 2, 3, 4, 5, 6, 7. So it looks as if this value right here is my Q1. This value is my Q1. And so I must have 7 values above that. 1, 2, 3, 4, 5, 6, 7. Very good. So that value that I've circled is my Q1. That is 33. So I can write that Q1 is 33. And then the middle of this top half now, let me circle this one, my 33. The middle of this top half, there are 15 values there again. And since there are 15 values there, it's friendly. So half and half, 7 and 7, my middle value is the 8th value. 1, 2, 3, 4, 5, 6, 7. So this is my 8th value. Then I have 7 values above that. 1, 2, 3, 4, 5, 6, 7. Beautiful. So I can know that that 2 right there is my middle of my top half. So this 2 is my Q3. Q3 is therefore 52. 52. 52. So those are my quarters and my median. So I can write them out here now. So my median Q2 is equal to 41. My lower quartile, Q1 quartiles. The quartiles are Q1, which is 33, and Q3, which is 52. Those are my answers. Any question there? Everybody good with that? Easy stuff.
sir.
Everybody good? All right.
Yes,
Yes,
sir.
Like CSEC. All right. Then they want, somebody have a question? Anybody have a question? All right, no question. Then now they want us to construct a box and whisker plot. Now remember, a box and whisker plot is a scaled drawing. All right, it's a scaled drawing. What are the values they're putting on the box and whisker plot? We're putting on the quartiles in the box, and we're putting on the lowest value, which is 10. So we can write that over here. The lowest value is 10, and the highest value is 64. Highest value is 64. So the range is from 10 to 64, and they're putting a quartiles in the box. So the whiskers coming out to 10 and 64, and the box is inside here. It has to be a scale drawing. So we're going between 10 and 64. All right. So I want to do somewhat of a scale drawing. Even though it's a sketch we're doing, we need to make it like a scale drawing. All right. So let me put this as my axis. I'm going between 10 and 64. So okay, if we start at 10, right here, I can go 10, 20, 30, 40, 50, 60, 70. So it's 10, 20, 30, 40, 50, 60, 70. You can use your ruler and make sure that the intervals are equal. It has to be a scale drawing. All right, I'm going to put on, let me copy these values down here. The values that I'm going to use. These are the values I'm going to use. Let's copy them down. Paste them down here on this side. Let's log inside, please. Oh boy. All right, so the first lowest value is 10. So I'm going to put a whisker right here for the 10. Start at the whisker. Then I need a box at Q1. I need a box at Q1. The box starts at Q1. That's 33. This is 30. It's about 35. 33 is about here. So I'm going to put a box there. Start a box there. Then another box at 41. So this is 45. 41 is maybe around here. And then the other one is at 52. 55 is there. 52 is maybe around here. 52. And I've complete the boxes. The whisker ends at 61, 64. So 60, 65 is around here. So 64 maybe is about here. And so my whisker goes out to here. And then this goes down to there. And I can put the values on it. Since I drew it with my free hand, I'm going to put 10. I'm going to put the 10. I'm going to put the 33 right here. I'm going to put the 41. I'm going to put the 52. And I'm going to put the 64. All right. That's that. Done. There's a comment on it. So the comment is usually whether it is positive skewed, or negative skewed. Now, I'm seeing that this whisker is longer than that whisker. but this box longer than this box. So it's sort of balance. I would say it's sort of balance, right? But if you prioritize on the box, it is slightly positively skewed, slightly skewed to the right. Right? Slightly skewed to the right because that box is longer, right? And you usually have more important data in the middle here. So it's slightly skewed to the right. But you could also say it's relatively symmetrical, right? Based on the fact that this is cut is longer than that one. So we have an elongation on this side and an elongation on the box. I'm going to use the box as priority. I'm going to say it's skewed to the right, slightly skewed to the right, slightly skewed to the right, because it's slightly positive skewed, slightly skewed to the right. I could say positively skewed or positive skewed, positive. Because of the box is a little bit longer than this one. All right. So I would give them that. And maybe tell them the reason why the box is prioritizing on the box, and the right box is longer than the left box. That's that. Okay, that's that. All right, this is probability. So we'll do this tomorrow. Rest of it is probability. We'll do the probability tomorrow. All right, let's go and do the 2022. Let's go and do the 2022. 2022 statistic right here. 2022 statistics. That is probability. That is probability. All right, this is statistics now. Let's see. Sometimes I wonder why CSEC gives so much data. I mean, they can test what they're testing without giving so much data, but no, everybody have to do the same question, so no problem. This question gives us this data. There are 27 scores there, right? And there are scores obtained by 27 students in the math test, right? These are the marks obtained by 27 students in the math test. So low score is 30, high score is 98. The good thing that they are already in ascending order, right? They are already in ascending order. So that's one of the good thing about it. I want to construct a stem and leaf diagram. So remember, the stem are your 10s and the leaf are your 1s, all right? So I'm going to set it up like this. Remember, you must present a key. I'm going to put stem values over here. That's 3, 4, 5, 6, 7, 8, and 9. 3 all the way up to 9 are the stem values. So it's 3, 4, 5, 6, 7, 8, and 9. I don't know why CSEC did that, right? So over here is my stem. Over here, I'm going to put my leaf. All right, ready now. Putting in leaf values. So I'm putting in the 30s. I'm putting in the 30s. So it's 0 for this 30, then 5, then 9. That's it for the 30s. Then will come the 40s. These are the 40s. These are the 40s. So it's 2, 5, 5. 40s done. Then the 50s now. These are only 2 50s. So it's 52 and 59. And then I have my 60s. This one and these. So it's 261. So it's 1, 1, 5, and 9. The 60s done. And I'm putting in my 70s. And these are the 70s. So it's 70, 71, 75, 77, 79. Then I'm putting in the 80s now. So it's 81 here, and then all of these 80s here. So the 80 is like the longest section. So it's 81, 83, 83, 85, 87, 89. Those are my 80s. And I come to my 90s right here. So it's 90, 90, 95, 98. You must present a key. You must give a key. The key is just give an example of one of the values. For example, I can say 45 is 45. 495 means 45. That's all I have to do. Just give any one example and do it like that. All right, that's it. But go to that.
Yes, sir. Yes, sir.
But go to that. State one
Yes, sir.
advantage of using the stem and leaf diagram. One advantage is that the stem values are not repeated. These stem values are not repeated. That's one example. So stem values are not repeated. Another example is that the data is shown in a compact form. The data is shown in a compact form. Another advantage is that it relatively shows the shape of the distribution. It relatively shows the shape of the distribution. It kind of shows the shape of the distribution. Kind of. I see you kind of get heavy down here, so right? Kind of show the shape of the distribution. All right. So I would say, for example, the stem values are not repeated. I can say the data is shown in a compact form, right? And it relatively shows or somewhat shows the shape of the distribution. Any one of those things are right. Only one example, one advantage. So stem values are not repeated. Consider stem values are not repeated. Right? Or another way, or you could say shows data in a compact form. Or we could say displays shape of the distribution. Displays the shape of the distribution of the values. Distribution of the data. So I give you 3, you only wanted 1. So one of those 3, right? You're good to go. There might be others, but those are the 3 that really come to mind. All right. Boom, bang, boom, bang, boom. Next one. State the range of values obtained. Range of values obtained by the student. So the range is the largest value, which is 98, minus the lowest value of 30. See there? 98 minus 30 is the range of the data. 98 minus 30. 98 minus 30, which is 68. That's the range of the values obtained by the student. Easy mark, 1 mark for that. Next part. So they gave us a box and whisker plot. The data are displayed on the following box and whisker plot. State 2 distinct observations about the data as seen on the box and whisker plot. 2 distinct observations. All right. Boom, bang, boom, bang. I know the quartiles. I can see them here. They are shown distinctly. And I can also say it is negative skewed because you have the same number of data inside here, but the values are spread out more in the lower half than the top half. You can see it. Over here, the same number of values, but the values are closer to one another. So the data is negative skewed, spread out more on the left side. So I can see the quartiles. Right? So for example, I can tell you I can see the median, for example. All right, so I can see the median value. What's the median value? Actual values up here? 71. Right, but I can see the quartiles. I can say that. See 2 distinct observations. The first thing I'm going to say, I can see the quartiles. Right? The quartiles. Let's write it, the quartiles. Quartiles are 52, 71, and 85. Remember this one's the median. All right, those are the quartiles. 3 quartiles and 85. And I can say the distribution, two things I want, distribution is the distribution of the data is negative skewed. The distribution of the data is negative skewed. The data is negative skewed, right? Because you have a wider range of values on the bottom half of the data. Same number of values on the bottom half, but they spread out more from 30 to 71. And it's the same number of the values you have less than the median. So those are 2 observations that I could make. All right, they are true. So you still have to give it your marks. Boom, bang. All right, let's go. Next paper, 2021. Let's see, 2021. We'll do the probability tomorrow, guys. We'll do the probability tomorrow. 21. I'm not going to bother to try to have a session tonight. I'm going to leave you to sharpen up on your bio. Sharpen up on your bio tonight. And Spanish. Bio and Spanish. Good luck in your bio and Spanish tomorrow, guys. So this question, they give us a box and whisker plot. All right, so I'm going to read the box and whisker plot. Like this way. As if it is this way. All right, so here corresponds to here. This is from the low value to the high value. Yeah, I have to make sure you observe that, right? Yeah, high value would normally be this way. So be careful and note that first. So up here corresponds to out here. Just have to put the box and whisker plot vertically, but if you put it horizontally, like so, then out here will correspond to here, 20, all right? That's all I'm saying. All right, so I'm putting this arrow to help me to remember that. So right now it is positive skewed, and I see there up is a taller, so it is positively skewed. Right off the bat, it is positively skewed, or right skewed. Question says, the scores of the students in the math test were used to draw the box and whisker plot. So the total possible score is 20 marks. All right, total possible score from the test is 20 marks. All right, 20 marks. All right. It says, you can see, so somebody get 20, somebody get 20, and somebody get 4. All right, it says, use a box and whisker plot to determine the median. So the median is right here. So median is right there. What is that? Let's see. That looks like, if you scale it up, like 11. Right off here between the 10 and the 12 is 11. So I'm going to write 11. 11 marks is the median. 11 marks is the median. What else? 1 mark for that. The range of the scores. The range of the scores, 20 to 4. 20 is the highest, 4 is the lowest. So it's 20 minus 4, which is 16 marks is the range of the score. 16 marks. Next question. The semi-interquartile range. The semi-interquartile range is the interquartile range over 2, which is Q3 minus Q1 over 2. All right, so we have to work that out, which is equal to, so we need to find Q3 and Q1. Let's look at it. So this up here corresponds to Q3. This down here corresponds to Q1. So Q3 equals what and Q1 equals what? Let's work them out. Going from left to right. So based on this, Q1 is 7. Right inside here says 7. And Q3 is 17 inside here. So 17. 17 minus 7. then it's going to be 17 minus 7. What an easy question. 17 minus 7 over 2, that is 5 marks. Interquartile range is 5 marks. Note I keep saying marks. Comment on the shape of the distribution of the scores. See, they're positively skewed. Because it's longer up here. This box is longer. The whiskers are relatively the same size, you know. But this box up here is longer. So it's skewed to the right. Skewed to the right, right? It's positively skewed right, skewed to the right. Right? Skewed to the right. Or we can say it is positively skewed, i.e. it is positively skewed, positively skewed. That's it, positively skewed. Anything else for statistics? All right, it says now, a student wants to determine the mean score from the data. See, one reason why it would not be possible to determine the mean score from the data. In order for you to determine the mean, you have to know the actual scores. You have to know the actual score that they got. And you cannot get the actual scores from the data, from the box and whisker plot. Right? You cannot get the actual scores from the box and whisker plot. You can only see the quartile and the range, the smallest and the largest values, right? So give one reason. So we can say the actual marks are not known from the box and whisker plot. Let's spell whisker again. W-H-I-S-K. Don't. Let's make sure. But I'm just call it a box plot. All right, no problem. Box plot. From the box plot. So you cannot get the actual scores from the box plot, guys. That's why. And in order to calculate the mean, you have to have the actual score. That's the reason. It's only one marking. So that is it. You need the actual scores to get the mean. It says, state what additional piece of information will be needed to determine the mean. We need actual scores, and we also need the number of scores. And that's another thing we can't get from box and whisker plot. We can't get the number of scores. You can't tell us the number of scores. Right? So we need the actual scores and the number of scores. What additional piece, we need the number of scores. So assuming that we don't have the actual scores up here, the next thing we would need are the number of scores. The number of, they told us the number of students up here. Let me see. Did they tell us the number of students? Yeah, it was 30 students. So we know it's 30 students, so we know that. So since we know it's 30 students, it's actual scores we need. I don't know why they asked me this again, what additional information will be needed. I don't know. State what additional piece of information will be needed to determine the mean. I don't know what else to say. I basically said the same thing. I need to know the actual scores. All right, so I'm going to say it here. I said the actual scores are not known. I'm just going to say I need the actual scores. Where to get the sum, I just add up the scores. So if I knew all the scores, I can add them up. No, the box and whisker plot only show you the quartiles and the lowest value and highest value. It don't show you the individual scores in between. Yeah. To get the mean, you have to add up all the actual scores and divide by the number of scores. Right? So state what additional piece of information would be needed to determine the mean. The actual scores, I don't know. I don't know the actual scores. One mark. I don't know what they want to say. I need the actual scores. Write what I need. Write out everything. I need to know the actual scores the actual marks and the have the number of marks already and the number of marks. So you calculate mean, you add up them, add up them. All right, let me just tell them the sum of the marks. Must be that, the sum of the marks. The sum of the marks of the 30 students. That's it. So I can tell them, because I'm saying here already that I need to know the actual marks. So to calculate the mean, I need to add them up. I need to be able to add them up. All right, so leave that. I need the sum of the marks. I know it's 30 students. All right. It says, given that the sum of the 30 scores is this, all right, so the LP must know. And the sum of the squares of the marks is this. Determine the standard deviation of the data. All right, so let's just know. Let's use the standard deviation formula to do this. All right, so the sum of the marks is this. So we can calculate the mean, you know. So you know, it means that the mean of the marks is the sum of the scores, which is 354. So how much like the help us here, so you know, guys. They say what was needed, and then they tell us what we need, and that's what we wrote here, the sum of the scores. So this confirms that we have the right answer. I know that it was 30 scores. All right, so the sum of the scores is 354 divided by the number of scores, 30. That's going to give us the mean. Write that out for me, please. And then give us the sum of the squares of the scores. The sum of the squares of the scores, and the sum of the squares of the scores are the sum. Oh man, the person off this thing. The sum of the squares of the scores. So this is giving me the mean. I'm going to use a formula. So I have this, and I have the sum of the square. The sum of the square of the scores is equal to this. 4994. Determine the standard deviation of a solution. So I have to use a formula now, the standard deviation, right? And it's on the formula sheet. Let's look at it. It's on the formula sheet. And write and then copy back down. Where is it? Where is it? It's on the formula sheet right here. So this is a formula for standard deviation, right? It's right here. Now, this is variance. So the standard deviation, you really have to square root this. See this now? You can use this formula now because they gave us the mean score, and this really is the sum of the scores. So this basically can be written as a simplified way, the sum of the square of the scores over the sum of F is the number of scores. I'm going to write it below here. I'm just writing a simplified version of this formula. Because all them sum of F and all them things are really, really bad. So the sum of the square of the scores over the number of scores, that's what that is, minus the mean score squared. The square of the mean score. That gives you the standard deviation. I'm going to have to square root it. That's just a variance right now. That's the standard deviation square. So I have to square root this. Right? You're going to have to square root this. And that will be the standard deviation equals that. Or the S, which is standard deviation. S is standard deviation. I'm going to copy this formula down now. I'm going to use that. Copy. I'm going to use that formula in here. And then we have the information that we need to get standard deviation. Share. Where is it? Pass it. No, see it here. Right down here. So just drop that formula here and put the values in there for the standard deviation. Somebody work this out for me now. What work out to?
Yeah, 11.8.
Get the mean. How much?
11.8.
11.8. So this is 11.8. So dropping those values in this now. So this becomes equal to the square root. The square root. This is the sum of the square that they gave us here, so which is 4994 over the number of values, which is 30. Right, it's better. 4994 over 30 minus the mean. Calculate the mean, this is what they gave us. 11.8 squared. Whatever that work out to is a standard deviation. Read that from please. What is that? What that work out to?
So I got 27.22.
27, you square root it. If you square root it now. 5.22 is the standard deviation. 5.22. 5.22 marks. The standard deviation of the marks. That's like a variance of the marks, or the marks vary from the mean. 5.22. That's about how much they vary from this mean. Right? That's what it is. All right. That's 2021. Let's continue. So there's a couple minutes left. Let's look at 2019. We are going on to 2016 still, so I'm going through them fast. All right. All right, so 1 year. So this one, I think 2019 was a crazy question and a lot of parts. Let's see. This is a crazy question. I think I'm going to leave this one, but almost. This is probably okay. We cannot stop here. All right, good. All right, this question gives us this is a two-sided stem and leaf diagram. So you read the side this way. So for example, this is 29. And we decide this way. For example, this is 29 girls. All right. It says the weight in kilograms of students in grade 5 are displayed in the following stem and leaf diagram. It says state the number of students in the class. So this is the count of these and count of these. That's how we have to do. All right. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 14 girls. And let's count over here. It is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 16 boys. It's 30. 30. Good? Are you good with that?
Yes, sir.
Double check. 1, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Is this 15 enough? It's actually 15. Let's check it again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So it's actually 15 over here, not 16. 15. So I give it away easy. So it's 29. 29. There are 15 over here. All right, 15, 14, and 15, 29. It says, construct one box and whisker plot for the entire grade of the boys and girls. One box and whisker plot. So to calculate the one box and whisker plot, we need to know basically what we can do now, we can combine this, and then do the box and whisker plot. We have all this space. I'm gonna combine. I'm gonna make one stem and leaf diagram first. Consolidate the values. All right, so I'm going to consolidate the values first. So 2, 3, 4, 5. Instead of trying to figure out the stuff and complicating it, I'm just going to consolidate the values and the one stem and leaf diagram first. So it's 888 on this line. It's 88899. All right, 88899. So it's 88899. Then here it's 22, 22, 33, 33, 5, 5, 7, 7, 888, 888, and then 999. 999. And then in the next line, it is 0, 0, 0, 0, 0, 0. And then it is 1, 2, 3, 4, 5, 6 ones. 1, 2, 3, 4, 5, 6 ones. And then you have a 5.
0 and 2.
Then you have a 5. Huh? You
So
have a
you
2.
have
Oh,
one.
you have a 2. Yeah, man, you have a 2 first, yeah. And then a 5. Good. Thanks for that. And then you have just 51. Now that I set it out that way, I can find my quartiles a lot easier now. So there are 29 values. Remember, there are 29 values. So that's 29 is what? 28 over 2 is 14. So I have 14 and 14 and the 15th one in the middle, right? 14 and 14 and the 15th one in. So I need 14 and 14. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So this 9 right here is my median, you know, that 9. So let me take out back all these marks. So this is my median right here. All right, that's my median. Then now I need of these 14 values, I need a halfway mark. So of the 7 values down here, 14 values down, I need a halfway mark of that 14. So the halfway mark of 14 is between this, you have 7 and they have 7. So between the 7th and the 8th, between the 7th and the 8th value going from left. So it's after the average of the 7th and the 8th value. 7th and the 8th value starting from the beginning. So it's 1, 2, 3, 4, 5, 6, 7. So the average of these two. Those are the two in the middle up here. Average of these two values is my Q1. So I'm going to mark it there. I know that I'm using those two for my Q1, right? Average of those two. 1, 2, 3, 4, 5, 6. And 1, 2, 3, 4, 5, 6. Good. Then the other half, I'm going from the back. So I'm going 7 from the back. I'm going this way. This way. Right? So it's 1, 2, 3, 4, 5, 6, 7. That's the 7th and the 8th. I'm averaging these two. All right. So it is these two. Give them my upper quartile. I can take this off. So this is my Q2 right here. This is my Q2. These two will give them a Q1 when I average them, and these two will give them a Q3. All right, so I can work them out quick and fast, and then draw my box and whisker plot. So let's put them over here. My Q1 is the average of 32 and 33. That's 31.5, you know. That's 31.5. Average of 32 and 33. Not 31.5, 32.5. 32.5, 32.5. And then this now, 12 is the same value, 41. Average of 41 and 41 is just 41. So Q3 is 41. And let me shift this down and put Q1 in between them. Q2, I mean. So Q2 is this value right here, which is 39. Q2 is 39. So this is a draw a graph now with these values. The lowest value is 28, highest value is 51. All right, so let me see if I can get something fast. I know that time is up. All right, I'm gonna start at, let's just start at 25. Can I go by 5? I'm going up to 50. So this is, let's say this is 20, 30, 40. That'll go by that. Can I go by 5 then? So 25, 30, 35, 40, 45, 50. Shift it over. All right, so I'm going to use this. All right, there it is. I'm going to put on my values. So the lowest value is 28. 28 is the lowest value. Use the same purple to draw it. 28. So 20. 8 would be around here. 25, 26, 27, 28, 25, 26, 27, 28, 29. So I want 28 will be around here. I want to put a line right here. 128. Our first box is at 32.5. So it's a 30 here, 31, 32, 33, 34. So 32.5 is above over here, 32.5. Our first box there. Then 39. 39 is about 35, 36, 37, 38, 39 is about here. I'll put my next box right at 39 there. And then 41, 40, 41, 42, 43, 44. So it's about 41 right here. And then the last one is 51. 50, 51 is about here. So that's the end of my last whisker. Bang, bang. And then I join my whisker. Join my whisker. I can put the values on it. This lowest value is 28. This value is 32.5. This value is 39. This value is 41. And this value up here is 51. And this box is clearly longer than that box. So the box shape is negative skewed. Right? That's my combined shape. Done. That's my box and whisker plot. It says, the standard deviation, oh, this is what I remember about this question. The standard deviation of the weight of the boys is this. It said, determine the standard deviation of the weight of the girls. Provide an interpretation. All right, so to calculate the standard deviation of the weight of the girls, you know, guys, a lot of calculation. Like this, about the formula, please. I'm going to use about the same formula. Then I need the mean. And then I need the square of the values to put in there. The sum of the square of the values to put in there for the girls. All right? So that's what I don't like. That's what I don't like about this question. So these are the girls. All right? I think it is too much work. So it's 28. Copy it down. 28 by 2. No, I have to write them out. I want to copy this information down. That's what I want to do. So it's 28, 28, 29, 32, 32, 33, 35, then it's 38, 38, shift over. I just want to get information down there to do the work. 38, 38, and 38. And then it is 40, 41, 41, and 42. These are the values. Copy these, paste it down here. Paste it down here. All right. So there are 15 values here. All right. 15 values. This is a 15 or 14. Just 14, right? 14. 14 values there. Let's make sure. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, right? 14 values there. So can somebody calculate the mean of them for me? The mean is the sum of those values divided by 14. So somebody needs to add them up for me and divide by 14 for me to get the mean. Then I'm going to need the sum of the square of the values. That's the next thing I'm going to need to put in the formula. The sum of the square of the values to put in there. All right. So the sum of the square of the values, the sum of x squared is going to be 3 times 28 squared. 3 times 28 squared. Then 2 times 32 squared plus 2 times 32 squared. Then 33 squared plus 33 squared plus 35 squared plus 35 squared then 3 times 38 squared plus 3 times 38 squared plus 40 squared plus 40 squared plus 2 times 41 squared plus 2 times 41 squared plus 42 squared plus 42 squared. Somebody need to work out all of this for me. Yeah, that's why I don't like this question. I don't think it is reasonable for exam paper, but they set it. 42 squared. That's give me the sum of the squares. I have to drop those in this formula, you know, guys. I need the mean to drop here, and I need the sum of these squared values to drop there. But then what I get for the sum of the square? Add up these for me. Sum of the squares. So much I get. Is that square? That's square. Sorry, that's square. That's square. 42 squared. I missed it. Come again, 17 and 72. All right. I'm going to work out to sum of these values now divided by 14, give it the mean up here. So then what you get? Add up these and divide it by 14.
So you get 35.28.
How much I get?
35.28.
35.28. So basically dropping those values in there not to get the standard deviation, make the circle smaller. So we can get more space to work. All right.
Okay, it's 35
So,
point, 35.29.
You get what?
35
29 yourself?
Yeah.
You get 35.29, neither here nor there. 2829, neither here nor there. Now make no significant. All right, so if I correct it, it's maybe 29. No, neither here nor there. All right, so we're dropping those values in the standard deviation now. So the standard deviation, S for the girls, becomes equal to the square root of 17772 over, there were 14 girls, minus the mean, which is 35.29 squared. And tell me what to get for this now. Where the sort and tell me what to get. Don't like this question. I think it's too much work. CSEC don't think sometimes when them setting questions, you know, and give 5 marks for it. But everybody have to do it. So what you're gonna do? What to get for that?
So 4.9.
4.9. All right. So standard deviation for the girls is 4.9. So look here now. It says standard deviation for the boys is 5.52. And this is kilograms, right? Kilograms. It's 5.52. And we have calculated standard deviation for the girls to be 4.9. And that's I must provide an interpretation of your answer of the standard for the answer for the girls compared for those of the boys. How do you interpret the comparison? How do you compare these two standard deviations? This one for the boys, which is higher value than for the girls. So how do you compare them? What would you say? It's quite easy. Since the standard deviation for the boys is higher, it means that the weight of the boys are more widely spread from their mean weight as compared to the weight of the girls. When the standard deviation is higher, it means that the weight spread more from the mean, right? As compared to when the standard deviation is lower. Since the standard deviation for the girls is a lower value, it means that the weight of the girls are more closely spread from their mean weight as compared to the weight of the boys. Simple. So if you're referencing what your statement from the perspective of the boys, you're going to say that their weight spread more widely from the mean. And you have to say from the mean weight in comparison to the weight of the girls. if you're going to reference your statement from the girls, you have to say weight of the girls. Since it's a lower standard deviation, the weight of the girls are more closely spread from their mean weight in comparison to the weight of the girls. So the key word, if you're referencing for the girls, it is that the standard deviation means that their grades are more closely spread. More closely spread. And it's a spread from the mean. More closely spread. Right? Since the boys' standard deviation is higher, is a higher value, the key word is that the scores or the weight of the boys are more widely spread. Widely spread from the mean. Widely spread. So your statement, if you're going to reference this, they are more widely spread. If you're going to reference this, they are more closely spread. So let's say I'm referencing the boys. All right, let's say I'm referencing the boys. I'm going to say the weight of the boys weight of the boys are more widely spread from their mean. It has to be from the mean. Standard deviation about how it's spread from the mean. From their mean weight as compared to the girls. As compared to the girls. All right, if you're referencing from the girls, you would say the weight of the girls, this is boys. You have to say the weight of the girls are more closely spread from their mean weight as compared to the weight of the boys. That's it. All right, that's it. That's how you have to interpret it. They said determine the number of students in the 20th percent. That's what the question along. That's what I don't like about this question. It just go on and on and on and on and on. I remember it. I remember it. Right? 20th percentile. So the 20th percentile of the student is like determine the number of students above the 20th percentile. So that's how you can divide the data into quartiles. You can divide them into deciles. Deciles is when you divide them by tens. Divide it into tens. Percentiles when you divide it into hundreds. And quartiles when you divide it into quarters. So if you want a 20th percentile, you want to know what the position of the, what score is in the 20th position. 20th position of the number of students. I remember the total number of students was 29 students, right? 29 students. So I go to the nearest whole number. All right. So the position of the 20th percentile, the position of the 20th percentile you calculate by doing 20%, 20 over 100 times the 29. That gives you the position of it. Then what that is equal to 20% of 29 is how much? 20% of 29 is what? Somebody wrote that out for me now. 5.8. So that's 5.8. And you wrote up to the nearest whole number, that's 6. That's 6. So you're talking about the 6th student or the 6th score. The 6th mark is a 20th percentile. So you need to find what the 6th mark is in the data. So go back upon the data now and look for the 6th mark. Remember, these were all the marks. We'll put them in one table. So the 6th mark we're looking for now. Let's use the purple to mark it. That's 1, 2, 3, 4, 5, 6. This is the 6th mark, you know. This. That's 32, you know. So 32 is the 6th mark. But guess what? This is also a 32. So the marks that are above 32, the 6th mark is 32. So i.e., 32 is the 6th mark, i.e. 32 marks is the 6th mark. You want to know how many marks are above that 32. So you want to count how many marks are above 32. So these are the marks below it. 32 and below. How much marks that? 1, 2, 3, 4, 5, 6, 7, right? 7 marks are below it. So it means that the rest of them are above it, which is 22 marks. 29 minus 20, 29 minus 29 marks. 29 marks, yeah. 29 minus 7. 1, 2, 3, 4, 5, 6, 7. That's 22 marks. So there are 22 marks above the 20th percentile. See it? Number of students. So that's 29. So therefore 22 students above. Now those 22 students get more than 32 marks. Basically, that's what you're saying. 22 students above. As simple as that. All right. All right. It's now 20 past. I'm gonna stop it here. 2019. If anything, we'll pick up back with this tomorrow. I'm gonna stop it here. We're gonna stop at 5 o'clock. I know people have their statistics, their bio and French to do tomorrow, and Spanish. So I've gone half an hour over. So I'm gonna stop it here. And I'll continue from here tomorrow, guys. From 2018. All right. All right, guys. But good. But understand this though. But understand that?
Yes, sir.
So percentile similar to quartiles, you know. You just start to take in percentages. So quartiles, I can divide the data by 4. The 4 equal parts. Percentiles, you divide it into 100%. You divide it up into 100%. Deciles is like a divided 10-10. So 10 equal 10, 10 tens. You divide it up into 10 tens, 10 parts. Deciles into 1 tens, 2 tens, 3 tens, 4 tens, 5 tens, 6 tens, 10 tens. So it's just other ways it's just different ways of dividing data. All right? It's a different median divided half and half. That's what the median does. Divide it in half and half. So you can divide it with the median, half and half. You can divide it with the quartiles, quarter. You can divide it deciles, tenths, in tens, 10 tens. Right? And then you can divide it into percentiles. 100% make a data. So like you divide it up into 1%. You divide up all the data into 1% to get 100%. So the 20th percentile is 20% of the 29. That gives us 5.8, which means you're talking about the 6th mark. The 6th mark happens to be 32. This question is asked, you know, for how many scores are above this 32. But there are 2 32s there, right? So you want all the scores that are greater than 32, and there are 22 scores that are greater than 32. Because there are 7 scores up to 32, 7 scores up to 32 and including 32. So them here 1, 2, 3, 4, 5, 6, 7 up to 32. So the rest of them out here is 22 scores out here greater than the 32. Just so happens that the 6th percentile, the 20th percentile, sorry, is the 6th score, which is 32, but the 7th score is also 32. And you wanted all the scores that are above 32. So there are 22 of them. Determine the number of students who got above that percentile mark. So 22 students got more than 32 marks. That's what the basically saying. And that is the answer. Hope you understand, guys. But let's stop it there. And we'll pick up again tomorrow. I think I'm going to start the class earlier tomorrow. All right? I scheduled it for, what did I schedule it for? I scheduled it for 4 o'clock in Jamaica and 5 o'clock in Trinidad, right? I think I'm going to start it at 2 o'clock. No, the exam in Jamaica will finish at 11:40. If I give an hour to reach home, you might it's going to be recorded. So if I have a second exam, you can come watch the recording. So if I give you an hour to reach home, you reach home at 1 o'clock. So we start it at 1 o'clock Jamaica time, 2 o'clock Trinidad time. So we're gonna start this session tomorrow at 2 o'clock instead, Trinidad time, 1 o'clock Jamaica time. And the aim is to just work up until we finish, maybe around 8 o'clock. If you have to work until 8 o'clock, 7 o'clock, 5 o'clock, 7 o'clock, 6 o'clock, whatever. Just work until we finish off everything that we want to finish. And everybody go and sleep and go and do the exam on Tuesday morning. All right, so I'm going to start the session tomorrow earlier because we did not get to the point that we wanted to get to today. We've gone a far way. We want to finish off the statistics and then we'll do the probability. We still have the inequalities to do and the linear reduction with the graph to do. And then we also want to have a little session where persons can just feed their questions. Any questions persons might have, they can just let me know and I'll answer those questions. So we're going to start that session tomorrow. It's going to be live again. So those who join late can still start by watching the video whenever you join online on YouTube. Right? So whenever you come, if you can come with us and start at the beginning because you have another exam, those who have Spanish, for example, you can come and watch the video and just play it fast and skip past what stuff that you know if you're comfortable and see if you can join us. So we're going to start tomorrow, 1 o'clock Jamaica time, 2 o'clock Trinidad time tomorrow. All right, that's the plan. And we'll work and try to see if we can finish the full revision. All right, guys. So see you all tomorrow. Good luck in your exams tomorrow, your bio and your Spanish tomorrow. Okay. Okay, everybody. That's it.
Otherwise,
All right, cool. Bye-bye.
Later, sir.
All right.